The US drone industry stands at a crossroads, one that could redefine everything that we know about the tools that we fly, the data that we collect, and the future of American aerial technology. Right now, many of the drones that you see behind me may soon be restricted, not from just being sold, but from even being flown, all depending on what happens with ongoing government discussions here in the US. But it's not all bad news. We have incredible homegrown technology right here in the United States. Innovative systems being built by American companies that most drone pilots have never even heard of. Over the past few months, I have traveled all across the country, meeting with these manufacturers, touring their facilities, and flying their systems firsthand, all to help you understand what's coming next and to prove that there are real, viable American alternatives ready to take flight. This is the US Drone Showcase.
As someone who's personally invested nearly $500,000 into DJI systems, I was just as concerned as many of you about the future of the US drone industry. What would happen if we suddenly couldn't buy or even fly the tools that we rely on every day? So I started digging. I wanted to find the best American-made alternatives that could actually meet the needs of real-world operators like myself, someone who's been in this industry for over a decade. But I quickly ran into these same problems many of you probably have. There's almost no information out there. No detailed breakdowns, no comprehensive videos, nothing that helps professionals make informed decisions. So I did what I do best. I took it public. I made a simple LinkedIn post, expecting maybe a few comments. Instead, within 24 hours, I was flooded with messages from founders and executives across more than a dozen US drone manufacturers, inviting me to visit their facilities and fly their systems. That's when I knew this needed to become something much bigger. Unlike DJI, most US manufacturers don't make their own radio systems. They mostly rely on two major suppliers, Sylvis and Doodle Labs, and those components are incredibly expensive. To give you perspective, one manufacturer shared their numbers with me, an invoice for a total of about $250,000 for just 40 radios, and that only builds 20 systems for them. Yes, this is a higher end system that they build, but it still shows how steep the curve is. It's why building a reliable US drone under $5,000 or even under $10,000 is nearly impossible. There are non-NDAA compliant options like this HearLink system that I have on my own drone that I built, all for about $1,500. But many of the new service contracts don't allow for these specific radios to be used. The second hurdle is payload integration. Chinese companies like DJI make both the drone and the sensors, so everything connects seamlessly. But in the US, drone manufacturers often had to integrate third-party cameras, LiDAR, and thermal sensors, each with different communication protocols. That can mean 2 or 3 layers of communication that all have to sync perfectly, or risk reliability issues in the field. So while it might look like a simple plug-and-play setup from the outside, the engineering behind that stability is anything but simple. Again, jumping back to the drone that I built, I only have a camera attached to the autopilot, and that's the only thing that's talking. If I had a gimbal in here, it would make it a much longer and more complicated setup, which again runs into that reliability issue. I don't have full control over this. I don't manufacture any of this, so there's a lot of back-end stuff that I have to make work in order for this setup to seem like it's flawless, where on the end over here, it's just, again, a plug-and-play option. The third challenge is software. Most US companies start with an open source flight software and build custom code on top. It's a smart move early on, but as they scale, that code base can become bloated, slowing down new integrations and updates. The good news is that many of these companies are using their new rounds of funding to develop their own proprietary ground control software, giving them tighter control and faster innovation cycles. These 3 hurdles, the radios, payload integration, and software, are the reason this industry moves slower and costs more to build here at home. It's easy to say, why isn't there a cheaper US option? But once you see what these teams are up against, you realize the truth. Building a drone is easy, but building a drone company is really hard, especially when they don't own the full vertical of manufacturing the components and actually building it. They're sourcing a lot of these pieces together, and yes, some of them are starting to manufacture their own components, but it's still incredibly expensive. These companies don't want these drones to cost tens of thousands of dollars, but when they don't have the same economies of scale as a company like DJI, it's really hard to do that. I mean, a lot of these companies have been around for a while, but these components still cost so much money. Just like what I was talking about with just the radios costing tens of thousands of dollars for one single system. How are you able to make a drone under $5,000 or $10,000 when a radio costs as much as it does? Just a few things to think about, as a lot of these US drone companies really get the bad end of the stick, or some people just think that they're ripping the American people off or just really any customer off, when I don't think that's the reality of it. The reality is everything behind the scenes that adds to the cost and not having those economies of scale. Something that I do think is going to change over time, but that's just what we're faced with right now. Now that you got a little bit more context about the US drone manufacturers and really the hurdles that they're facing, I wanted to do that so that you had a little bit more context going into what all of these systems are. Now, the way that this video is going to work, that this is a US drone showcase, not a showdown. So I'm not pairing any of these companies up against each other, as all of these systems have different purposes, different use cases, different environments that they're going to operate within. Now, as someone who has been in this industry for well over a decade, my primary focus is drone mapping and LiDAR data collection. So that is mostly where my perspective is going to come into play. I'm not going to talk about any of the military or DoD applications of the drones. I'm also not going to talk about the search and rescue and law enforcement side of it, as there are a few companies that primarily focus on that in this entire showcase. Again, I'm going to go at it at the perspective of someone who collects data to sell to clients as a service. So I just wanted to put that up front and center so that you know where exactly my perspective is coming into play when I talk about these companies. And again, given that none of these companies spent a single dollar on any sponsorship of any kind in this video, I'm going to be brutally honest. We're going to meet with these companies, look at their manufacturing capabilities, look at the actual systems themselves, get hands-on with it, but at the end of each manufacturer that we meet with, I'm going to give my unbiased perspective on it, my opinions, what I'd like to see change, and what I'd like to see them improve on in this entire US drone market. And to make things a little bit easier for you to navigate through this entire video, since it's all going to be in one, and you can probably see how long this video is, I put everything into chapters, so you can skip around and take a look at which systems that you want to take a look at and get more information about. I'm also going to have a resource in the description down below that actually gives a full detailed explanation of all of these systems, what they are, what they support, and how much they cost, and who the actual manufacturer is. So if you want to take a look at that, it's either going to be a spreadsheet or just a web page that outlines everything that we covered in this video. One last thing before I actually take you guys into our first US drone company. I didn't get to meet with all of them. I wish I did. I just ran out of time and ran out of personal funds to fund this entire project. So we met with about 11 different manufacturers and one testing ground, but I will be talking a little bit about the other companies that I get to meet with and giving a little bit of my perspective and where they fall within the space. So with all that being said, let's go ahead and jump into our first manufacturer.
So if you can't already tell where I'm at, hopefully the hints behind me are giving it away, but welcome to Freefly's headquarters here in the state of Washington. Not only are we going to learn more about what they're actually providing to the commercial and industrial space on the drone side, but they actually do more than just drones. And I'm gonna take you through their entire facility here. We're also going to get some hands-on with one of their newer systems that they are releasing to the market. And overall, just going to give you my entire opinion about this company, what they're doing, and where I think they are going to hit the nail on the head in multiple different segments of this market. But first, let me give you a little bit of a history about Freefly, because Freefly as a company actually has a special place in my heart. So yes, this is going to be a little biased, but back before I was in drones, I was doing a lot of video production. And there is one very specific YouTube video that I watched. I'm gonna play a little bit of a segment here right now that is seared into the back of my brain. What you're seeing there is their Movi M5 camera gimbal. And from there, I actually bought one myself, and I've actually owned a few different Freefly systems on the cinematography side, primarily their camera gimbals. And well, they really started out as a cinema company, creating high quality productions with their own gimbals that they created, and then eventually built drones to help support that for that aerial perspective. And well, now they have a huge product lineup of not just gimbals, not just drones, but controllers, batteries, new sensors, a whole lot more. So I'm actually gonna walk you guys through all of that, show you where everything comes in and how everything goes out. So why don't we go ahead and start this entire tour and learn more about the US manufacturing capabilities that Freefly has here for the drone industry. Before Freefly builds any of their systems, they have all of their raw materials. They do almost all of their manufacturing here in their brand new 75,000 square foot facility. So material like carbon, foam, cases, even small components like PCBs and any of the boards that are going into these actual systems themselves, they start here. Now, something that I actually learned about is what you're looking at is about $10 million worth of just raw materials, which is gonna help support about 2 years of full production. Yeah, the life of every system starts behind me here. Now, something all of these systems have in common is they need power. So we're first gonna take a look at where they actually manufacture all of their batteries for the drones, their gimbals, and some of the other systems that they have. And that is this line that you see right here. So they actually purchase all of their cells directly from Samsung, but when it comes to their battery management system, all the boards, and even the housing, that's done right here. Now, this first area that I have right here is where all of just the raw components come in, they assemble it, and then behind me, this blue machine, they actually press and solder everything together. And then as it makes it down the line, all of the housing, the casing, and all the way at the end of the assembly line is where they actually do the testing to make sure that the batteries are functioning properly. Now, before we move on to the next station, I wanted to show you really the end of this assembly line for their own batteries. You can see here they actually have 3 different bays for doing their battery testing. So this really takes it through multiple different modes to ensure that, hey, are the batteries functioning the way that they're supposed to function? They can do that right here, fully automated. And that goes through for every single battery that they actually manufacture. They're not just putting it together and shipping it out. They take it through this entire very extensive process to ensure quality on every system that they put out. Now, as for the actual systems themselves, there's 2 assembly lines here that are set up to either build the Alta X or the Astro Max. And all of the shelves that's actually right behind the camera here have all of the individual components. So right next to me here, I've got one of the motors that they actually put into these systems. This one actually happens to be one of the gimbal motors where they actually manufacture their own gimbal. Since that's really where they started making cinema gimbals, they actually manufacture all their own gimbals that go onto the Astro and even the Alta X. But yeah, you can see there's a few gentlemen behind me here getting the systems set up and actually putting them together, doing full diagnostics, putting the boards together. I mean, it's pretty legit here. Now, it's not just the drones or the batteries that get manufactured here. They also do their own controllers too. So this is one that's fully ripped apart. Behind me, he's actually assembling the actual components where the board goes in. But yeah, this is all just raw material. There's nothing being shipped in from anywhere else to get this done. Like, they manufacture all of this here. What's also great about these controllers is you can get 2 different variants. So they have an NDA compliant one, or you can just get the HereLink one, which I think most people that aren't doing any government work tend to go towards. But yeah, they give you that flexibility to choose either option, and it's all done right here. And as you can see, once we make it all the way to the end of the assembly, this is what the final product looks like. So this one here is set up for the HereLink, specifically for the Astro. They have stuff here for the Alta. Yeah, just different variations here, depending on what customers order. So one thing about these systems, it's not just about putting them together and then shipping them out the door. Behind me here, they're getting software set up on it, and it actually goes through a few other iterations before it even touches the final flight test area. They have a few testing bays to just throw them inside of, to just do some burn-in to make sure that it's operating properly. And then once that is all said and done, then it can go outside to get the final flight test before they ship it out to the customer. Now, one of the very last areas that I want to show you before we actually take a look at the flight test is the RMA side. So any systems that they have, whether it's their Mobi, whether it's the Astro, the Alta X, their controllers, cameras, it all comes here if it needs to get fixed. So if a drone crashes, if a gimbal breaks, rather than sending it to a dealer, they actually do all of their own in-house fixing. So they've got multiple different areas set up. This is actually kind of the outbound And then all the way behind me here is all the inbound. So any of the systems that need fixing starts back there and makes their way all the way through both of these aisles that I have to the sides of me here. I really think that speaks to how confident they are to get their systems in and out. They have all of these different stations here specifically tailored to whatever product SKU that they're working on, whether it's battery manufacturing, which is just to the left of me here, or the Astro or Alta X, or the controllers, or the Movi systems, or the cameras. I mean, you can kind of see I keep going on and on here, but they are really trying to bring everything as in-house as possible. And I think they're doing a pretty damn good job at that. Before any of the systems actually make it out to customers, this is one of the final areas that they go through to get testing. You can see they have a few Alta X's here, and on the shelves behind me, there's a few Astro Maxes that they're now starting to ship out. But yeah, before any drone hits a customer's hands, they do all of their initial flight testing here to just make sure all the parameters are working. If anything comes back as a weird bug or an error, well, guess what? It goes back to the RMA area to go get fixed to make sure it actually functions before it makes it out into the real world. You can see they're very particular in terms of how they actually go through and process all of these systems before they make it out into the real world. So I did mention that Freefly doesn't just manufacture drones and gimbals and controllers, but they've actually brought in a lot of new in-house manufacturing. And a conversation that I actually had with Matt at Freefly was one of the issues that they constantly kept running into is they would have about $1 million worth of drones ready to ship out, but they'd still be waiting for the foam cuts to go into the actual cases themselves. So given that they got pretty frustrated with that, you can hear it is pretty loud behind me, but they decided to bring their own in-house foam cutting for their cases. That way they don't have to be dependent on anybody else to get that through. The cheapest material is the actual foam itself. You can get that by the dozens or even the truckloads, but getting the actual foam cuts for the cases, that's another story. And so they've decided to actually bring that entire process in-house. That way there is no dependency on anybody else. Now, something really cool that Freefly has been heavily investing into is more products, again, outside of just the drones, the gimbals, and the controllers. They're actually developing their own camera systems too. So we'll take a look at their Ember line, but something new that they're providing to the market is their own LiDAR line called Flux. And behind me here is one of 6 CNC machines that they are getting up and running. This is gonna be their testing and R&D one, and then there's gonna be several other ones to the side of it. But yeah, they're gonna be doing their own cutting here for their own LiDAR systems, which that's incredible. I don't really see any other companies doing that to be able to actually bring it all in-house and manufacture their own camera payloads. Really, really cool stuff. Now, this smaller side of their entire facility here at Freefly is the Ember side. And Ember is their slow-mo, high-resolution cameras that they've been building. Honestly, a really cool product. And if I was still in my production era, I would absolutely buy one of these cameras. But yeah, they actually build and manufacture it. You can see there's some tooling going on right behind me. But yeah, it's all done right here. Now, one of the things that I did talk about that I really like what Freefly is doing is their integrations. So they already have a ton of camera integrations with both Centera and the ILX, so for your photogrammetry side, and they've already had integrations with other LiDAR sensors. But now with their Flux line, this is their actual own brand, they're bringing to market 3 new LiDAR platforms. Although these are all very familiar LiDAR sensors themselves, these are direct integrations into their entire ecosystem. So here we have the Flux H1. This is using a Hesai sensor with I believe it's a 20 megapixel camera on the bottom here. And they actually all have 20 megapixel cameras as standard. So this is just a well-known high quality sensor. This is their entry level one. It's called the L1. So it's using a Livox with, again, another 20 megapixel sensor. And this is actually coming in at what I see here, $14,000. And the best part about all of the LiDAR sensors that you see here, there are no software subscriptions and you don't even have to pay with software. It comes with it. And you're actually gonna see it when we do the flight out live in the field. The live LiDAR data collection with specifically this guy here, but also works the same on these other sensors. You're actually processing the data on an iPad, which is kind of mind-blowing. You'll see that here shortly, but it's insane. And then the last one is they did keep NDA compliancy in mind. So they actually have the O1, and this is using the Ouster LiDAR sensor, again, with another 20 megapixel camera, but they're all using the smart dovetail mount. So now that we got to see the entire manufacturing of these systems, obviously it's not just the drones, but it's the controller and obviously their new line of plug and play LiDAR. Let's go ahead and actually take it for a full flight. So I'm gonna show you the mission control, how to set up your mission plans. I'm gonna show the really cool feature in the real-time viewing of the LiDAR data, but also the processing that you can do on the iPads, which is absolutely mind-blowing, but also show you the full just ease of use of the Astro Max system. So this small package right here is packing a punch. You're getting about half an hour of flight time with hot swap batteries here, and with their LiDAR integration, they've actually been able to do not a triple band, but a quad band GNSS receivers. So L1, L2, L5, and L6, which that's actually pretty mind-blowing itself. And you can see there's actually 2 antennas on top, so they're actually feeding both in there, which gives a whole lot more data when it comes to the processing side. That way they can pick whichever bands are more favorable, but that's a whole software side I'm not really gonna get into. But you can see on here I have the L1 setup, so it is a plug and play, truly is a plug and play, and we're gonna walk you through the entire mission planning right here, and we're actually gonna do an entire flight in real time. So first, I'm gonna go ahead and get our system set up over here. So now taking a look at the mission control here, you can see they've got a nice, beefy, very comfortable controller here for all of your mission planning, but also just full confidence and control of the system itself. Now, what's really unique about this specific setup that we have with the Astro Max and the L1 is it's running an iPad and the Alterian mission control. So that's why you've got 2 screens that you're working on here. One is specifically for controlling the actual LiDAR itself, which I actually really like. But simply here, we're just gonna create a very simple mission plan. I'm here at Freefly's headquarters here, and what we're gonna do is go and create a mission plan. Now, given that I have very early access to this, they haven't gotten the profile built into there yet, but when you're doing your mission planning, let's say we want to create an area here, we'll create a very quick survey path right over top of where we're at right now. We can go in and set our flight speed. So with LiDAR, typically 5 meters a second. With this specific LiDAR sensor, overlap, something like 30% overlap, and then our side overlap, 30% is totally fine. Now, when it comes to the actual camera, right, again, this is very early access that I have. They will have that parameter in there specifically for whether it's the L1, the H1, or the O1. But you can also see all of the different camera systems that are plug and play. Given that they have their smart dovetail system, which we're gonna take a look at a little bit more later on within this portion here, you can see how easy it is to hot swap multiple different payloads depending on what your mission plan is. So we're just gonna do the custom camera with everything that we have on here, but we can see that it's gonna take really not that long, about 2 minutes to do the entire flight. So once we're comfortable with it, all we have to do is click upload. Now it's uploaded to the actual system itself. And if we go here to the fly, before we click fly, we actually need to start the LiDAR data capture. So one really unique feature here, hopping onto the iPad, we can actually see the sensor itself and all of the parameters, all of the data it's telling us. So really, really cool. And it also brings in the actual Astro data itself. So before we actually send the drone up in the air, we need to just click on start recording. Now that it's recording on the mission planner itself, we'll click plus on the mission, hold to confirm. And there goes our drone. And like really any other system that flies autonomous, this is gonna do the exact same thing with ease. What's also great, we'll take a look a little bit more in the Alterian mission control. We've got full FPV view of the actual system itself, so it gives us a lot more confidence in terms of where the actual system is flying. That way, if we ever need to take over, we have full capability to do that here. Now, something that I do really like the implementation that the Freefly team has done is RTK through Ntrip, which that's not an easy thing to do in terms of the integration. They have it working flawlessly here. There's actually an LTE modem baked directly into the drone itself, so you can pretty much put in whatever service provider you like and then use RTK that way. So whether you have your own base setup or if you're operating on a node system, something that I like to do, then this is perfect here. But yeah, I mean, it's gonna fly as expected. This thing's actually very quiet and it's very simple to get up and operational. Not something that I think people should really worry too much when it comes to, jumping over to a system like this. But we can see we've been gathering data this entire time. All the talam is being pulled through, and we are just about to finish up with our flight right here. And there it is, it's already returning home. And just like that, super easy to do a full operation of LiDAR data collection. Once you're done, all you gotta do is click the stop button, and now it is fully saved. And then to do the data processing, super simple. I'll show you that here very shortly.
Okay, so at this point we're done. I'm done talking to Flux, connected on the drone, so I'll just kill that. And then you can add to an existing mission or existing project, or you can create a new project. So you define your, coordinate system, and we can just call this demo 1. There we go. So create the mission, we'll go into here, and then we'll go ahead and process the scan. So we'll just create Flux scan, and then we'll plug in our drive here. And so Flux scans, and then this is a scan that we did of these power lines.
Okay.
Obviously a little bit longer mission, but this is the same exact place that we just flew. So we did a couple of different tests on this day. I'll just pick, I think this one's L1, the other one's H1. So I don't know, do you have a preference on?
It doesn't matter.
Okay, so we'll do the L1, and basically, so right now it's importing the scan to the iPad so that it can use the super fast SSD and GPUs and whatnot on the iPad. So at this point we've imported the scan, so it looks like it was a 5-minute scan, and then we'll just select which variant of Astro we used, and then we'll select the base station file that went along with it. In this case,
same folder.
Yeah, so if you use the RTK, it'll automatically generate the base station file, and if you use another base station, you just add the folder to your iPad. You'll select that, and then we'll go ahead and run through the processing of this. So you can see we have L1, L2, L5, L6, and it's going through and processing the antenna corrections.
Yeah, this is happening really fast. Okay.
Yep. And so it'll go through that, and basically it'll optimize the path, and it's comparing the GPS antennas with the internal IMU to give you a really accurate path that the LiDAR took, so you have some pretty good data. So it'll run through that, and then we can see the antennas got fixed, and so then the next thing it's doing is aligning the GPS antennas to the IMU scan. So we finished processing this in 1 minute and 29 seconds.
That's crazy.
So we'll go here, and then basically here's the data that we flew. So
oh man,
there's this, and you can, it's your standard LiDAR processing workflow, so you can adjust your height, you can look at
and everything else,
all of that kind of stuff. You can, trim the data set way down.
So is this only
an
iPad app, or do you guys have a desktop too?
So only iPad to start, just to keep everything field processing wise.
Got it.
So we'd love to expand that in the future, but to start, it's iPad.
It's no surprise that Freefly continues to deliver exceptionally well-engineered systems, and the Astro Max stands as a testament to that reputation. Having had that hands-on experience with earlier versions of the Astro, I was genuinely impressed by how far the latest generation has evolved. The Astro Max has quickly become one of the strongest contenders in the commercial and industrial quadcopter segment for aerial data collection. Everything about it, from its refined design to its overall durability, reflects a deep understanding of professional grade requirements. During my visit, what truly stood out was Freefly's manufacturing capability. Their recent move into that 75,000 square foot production facility underscores their commitment to scaling precision manufacturing without compromising on their quality. It's clear that Freefly isn't cutting corners. They're investing heavily in building robust, high-performance systems that meet the exacting demands of modern aerial data professionals. This level of craftsmanship and infrastructure speaks volumes about their confidence in the product and their dedication to setting a new standard in the American UAS market. Freefly's long-standing reputation across the drone community remains well-deserved. Many professionals I personally know rely on the Astro Max and Alta X for their operations, and their consistent satisfaction reflects the company's focus on quality and reliability. My familiarity with Freefly actually predates my entry into the drone industry, back when they were best known for their world-class gimbal systems. Their deep expertise in motion control, motor design, and precision engineering has clearly carried into their aerial platforms, resulting in drones that strike an ideal balance between performance, reliability, and durability. That legacy of craftsmanship is evident in every aircraft they produce, but the feedback from the community reinforces it. Pilots consistently praise the build quality, the software refinement, and iterative improvements that extend system longevity and enhance performance in demanding field conditions. From my personal experience, I was thoroughly impressed by what Freefly has achieved. From my earlier days using their gimbals and film and photography to now seeing their evolution into building world-class aircraft. Their systems don't just look good on paper, they perform exceptionally well in practice. During my hands-on demo, setup was seamless, and the system flew with precision, stability, and honestly, a lot of responsiveness. It's rare that a drone impresses me to the point of immediate purchase consideration, but the Astro Max did exactly that. I fully intend to add one to my own fleet because I believe in the engineering behind it and in the company's mission. That belief is echoed throughout the professional drone community, where operators trust Freefly systems for their consistent performance and again, their unmatched reliability. At the time of this review with them, Freefly's main challenge isn't really quality. It's actually capacity. Demand for the Astro Max, Alta X, and other models have outpaced production, resulting in a 3 to 4 month backlog for new orders. While some components may ship sooner, securing a full system often requires patience or hopefully finding one through an authorized dealer that happens to have some in stock. Another consideration for potential buyers is the cost. The Astro Max and Alta X are not inexpensive systems, but their pricing is fair when placed in the context of the professional markets they each serve. Each aircraft integrates top-tier radios, materials, and software. Choices that reflect Freefly's dedication to performance and reliability over the cost-cutting that maybe some other manufacturers may opt for. One of the most exciting developments I witnessed was the company's direction announced at Freefly Fest earlier this year. Their proprietary LiDAR payload, designed for the smart dovetail mount system, can also be adapted for use on other aircraft, an approach that positions Freefly to lead the LiDAR and mapping segment in a very big way. The team's engineering discipline and vertical integration strategy are clear indicators of that ambition. Even during my visit, their new manufacturing facility was still being outfitted with the latest machinery, emphasizing their dive forward to complete in-house production and self-sufficiency. Freefly isn't distracted by the politics of the drone industry. They're focused on building solid, reliable, American-made products. You can actually feel that conviction throughout the facility. Every employee I met believed deeply in the mission and in the hardware that they were producing. Freefly's steady growth, manufacturing discipline, and forward-thinking design philosophy sets them apart as one of the strongest contenders in the Blue UAS and NDAA compliant space. They're expanding responsibility, scaling production while maintaining their hallmark build quality, and continuing to innovate on every front. Airframes and electronics to payloads and software integration. Again, their dedication to engineering excellence, coupled with genuine passion from the team, reinforces why so many professionals trust their systems for critical operations. In my opinion, Freefly is on track to not only dominate the US commercial drone market, but also to redefine what reliability and craftsmanship mean in the era of modern aerial technology, again, as a US drone manufacturer. I think 2026 is shaping up to be a pretty big year for Freefly, and I think they know it too. For more information about Freefly, check out the link down below. Now, let's move on to the next system in this showcase.
Welcome here to about 73,000 square feet of manufacturing, not including the other 50,000 square feet that they have on site. I'm gonna take you guys around to show you exactly how Skydio manufactures 3 different product lines, but primarily their X10 and X10D. So let me take you around and show you all the different components, all the different stations that goes into actually building these systems. And to be honest, it's pretty impressive. So this first area that I'm gonna show you right behind me here is the training facility. So just about over the last 2 weeks, they brought on about 20 new hires, and rather than just throwing them straight into the production line, they bring them back here and they actually go through a proper training process. That way they're able to ensure that every single X10 or really any system that's being worked on is done properly. This is where they mitigate any errors. That way they can meet their production standards of about 1,000 systems a month on the X10 side. Now, not every single system that is manufactured here is brand new. They obviously have their RMA and their reassembly and basically fixing anything that happens out in the field. One really cool thing that I did learn about is specifically for their enterprise and their government contracts that they have for clients is in the process where a system goes down, oftentimes they can get them a brand new one within 24 to 48 hours, just depending on the severity of it and how quickly they need a system out there. Now, part of the entire manufacturing process is they actually have 3 different kind of setups with the systems themselves, whether it's different payload packages, different radio packages in the system itself, right? All of these have different components and different, really a tier list that they have to go through. So part of that quality assurance, alongside with getting the repairs done, goes through one of these assembly lines that we see here. Now, this is where the senior technicians will go through and do the final validations before these systems get back out. But there's rows and rows of these assembly lines for, again, that QC and QA check before they finally go out to the end client themselves. So what we're looking at right here is what I like to call the final assembly loop. It's all of the arms, the body, the chassis, the chest, every bit of component that makes an entire X10 or X10D goes through this loop right here. You can see this sign right here, final assembly. Where we first started was the QA and QC before it actually makes it out to the end client themselves, alongside with any repairs or RMAs that need to be done. So every single component that goes through, they actually have a really ingenious fail-safe system where every component, every chip, every part that goes in every single system is scanned into a system to ensure that, hey, these are the right components that are actually supposed to go into that final system that goes out to the end client. So there is absolutely no way that any steps can be skipped, any shortcuts can be made. It's all validated here. No matter what controller, what radio, what payload package, this is the final assembly loop we have right here. So this room in here is actually the indoor test. It's actually kind of warm, very spongy place here, but they do all of their camera calibrations in here to make sure that there's no different vibrations that's happening. Again, everything that you're seeing here for the full QA, QC is not just what happens here in terms of the actual manufacturing, but what they actually do to test every single system before it goes out. So yeah, all of these walls here are padded. They have a little bit of a unique environment in here to ensure that all of the obstacle avoidance sensors are properly working and that they're not doing what they're not supposed to do. So they actually run it through this automated sequence to calibrate every single camera, not just the main payload camera itself, and I'm pointing at an X10 right in front of me, but all of the other vision sensing systems that are on the drone as well. Now this area over here is probably my favorite part of the entire facility, as this is where all of the gimbals get their assembly. So obviously there's 3 different variants of gimbals. They're all assembled here. I'm a gimbal nerd. I like all the technology that's in these camera sensors, especially with the camera sensor and the camera package that they have as options for the X10. But yeah, all of that is assembled right here. One really cool thing about the process here at the manufacturing is the actual arms for the drones. So when they are first put together, it's actually 2 pieces of plastic. And this machine behind me actually fuses both of them together to make them strong and rigid. That way there's no flex of like what we have right here. You can see there's a ton of them around. There's a few arms that are about to go into this machine right here to create that bonded fuse to give it that strength and rigidity when it goes through the final assembly process here. Where we're at right now is the pack out. This is pretty much at the very back end of the entire manufacturing facility here. And what we have is the ready kit. So as you can see, this is just ready to pull out. And ultimately they make it a very simple pack out process here so that whenever their client gets it, they can go out into the field and immediately deploy it, whatever the mission is. And now for probably one of the coolest parts of the entire manufacturing facility is their dock line. So here we're at the beginning where it gets its initial assembly, and then all the way at the end, you actually just saw they have their light tunnel. So these are all the different stages. Think of it kind of like an automotive line, which one of the cool things about this entire line is they worked with a lot of like automotive manufacturing engineers to set this up. Given that these are bigger components, not necessarily like small little tiny components like what you see in like a cell phone, they designed it in a way to make it very effective and efficient. So as you just saw, up here on the rooftop, there's actually a ton of these different docks from their latest generation to their oldest generation. And this is where they conduct a lot of testing, multiple different scenarios, multiple different applications, depending on what their clientele needs are. And that is actually one of the really cool things about the difference from both their manufacturing facility and their headquarters is this right here. And one of the main philosophies that Skydio enforces is continuing to learn from their previous iterations. What we see here is just the accomplishments that they've made over almost the last decade that they've been producing products. Dock operations is absolutely huge. I mean, this is something that they launched earlier this year in 2025, but it's also a massive part of the industry, not just what Skydio is focusing, but many other companies as well. So when it comes to the operations side, when it comes to the testing, when it comes to the different kinds of environments that they need to put it through, this is one of the prime examples that they have here. And given that it is here at their HQ, it allows for their R&D team, their software team, their integrations team, any team to get as much iterations through without having to pop back and forth from manufacturing to here. Really cool that they have this going live, and you'll probably see it quite a bit of multiple different X10s, different variations of systems flying all over the place here. Let's now get a hands-on look with the X10 system that I have right here. I'm gonna run it through a very basic mission planning and data collection workflow for more mapping, not necessarily an inspection side. Now, I do want to be fully transparent with you guys. My time out in California, I had practically no time to get hands-on at their facility there. So I did ask them to send me an evaluation kit, and that's all that they did. They have zero expectations for me to post anything about it, say anything good about it. So this is gonna be a very authentic, real-time impression of actually flying and operating this system. So I just wanted to be transparent with you guys so you didn't think that they slid anything under the table to me. This is gonna be really my second hands-on time with it so that I can bring this content to you and really show you how this system actually operates in a commercial mapping setting. So we have their VT300Z camera system on here, which does have a 50 megapixel main camera on, and then I just have one of their standard remotes. One thing I found a little ironic is the actual remote controller itself. And let me show you here. The ergonomics, I think, are honestly just fine. However, the screen is actually powered by a Samsung Galaxy phone, which I just find really ironic. You know, that aside, it is a bright enough screen. They are looking to actually develop their own handset as opposed to just adopting a big phone onto a controller like this. But in terms of the operation side of things, it is relatively straightforward. Again, I think the ergonomics are fine. There is a USB-C port on the back for charging and a full-size HDMI. Now, the full-size HDMI only shows what the actual camera is looking at. You don't actually get any of the telemetry to feed through. And unfortunately, for when I'm actually gonna show you guys how to do the mission planning and data collection, I can't screen record. So I'm gonna do the best that I can with this camera here to show you exactly how to operate this. But again, given that it is a standard controller here, we have both joysticks. There are some programmable buttons on the back. You do have two rockers so that you can change the camera zoom as well as the gimbal tilt. In addition, there are a few other more programmable buttons on here. There's a menu button, and as well as to power on, and then a quick play pause for your mission, and a return to home and land setting. As for the drone itself, they actually did send an RTK module, so we actually will be flying with RTK. I'm just gonna be using one of my local base stations that I have here, and then using my cell phone as the hotspot to connect the actual controller to the internet so that we have RTK capability. So that actually is a huge plus for me. I do a lot of high precision mapping and modeling, and this RTK module is essential for that, especially with some of the Chinese counterpart systems that I typically use. As for the small form factor that this drone is, this is on the bigger side of the small form factor. However, I would say honestly, the build quality is actually pretty solid. And you did get to see the entire manufacturing facility just a few moments ago. And I do have to say, like, this thing is actually built pretty well. The concerns of the batteries falling out, I can kind of see that because all I have to do is just push up, and there's really no locking mechanism to keep this battery in place. I think it's held in by magnets as well as just force. So the way that I put this battery in is I just let it sit at the top, and then I just let go and it just collapses in place. There isn't really a way to ensure that it's locked in, so I'm just kind of trusting it at this point. And then of course, Skydio is known for their autonomy engine, meaning with all 6 of these high resolution cameras on the bottom and the top of the drone, it creates this full 3D environment so that as you're flying around, it can do real-time obstacle avoidance, detection, and really allow you to get up close and personal with whatever it is that you're doing your inspections on. Now, one thing that I do not like at all is the subscription factors that Skydio has gone after when it comes to the functionality of the drone. I'm just gonna do a bit of a direct comparison to DJI. DJI gives you a lot of functionality straight out of the box, and they do not charge for that. They do charge for it for your initial one-time purchase, but they do not charge you to actually leverage the automation that some of the newer systems have in place. And with my time of owning a Matrice 4 Enterprise and a lot of the newer updates that have come, especially in the last 6 months, and some of their new AI modules that you can actually throw on, again, there's no subscription for it, it kind of puts this to shame in the software and automation side. This drone is very capable, but the fact that you have to pay a subscription to just do the mapping and some of the other functionality it has that should, I feel like, be built in, I don't like that at all. And that's not a fair cost to throw on to individuals like myself. Now, I know I'm a minority when it comes to who's actually leveraging this platform. It's more aimed towards larger organizations that are gonna have a fleet of these. So that subscription cost is just kind of baked into the service costs. But as someone who is a freelancer and has been a freelancer for a very long time, I always have to consider all of these different costs, all of these different subscriptions that I'm having to pay for software, for insurance, for all these different things. And the fact that this just doesn't come with that built in, I really don't like that. If they gave me a more, let's say, basic version that just let me do the mapping with RTK instead of the whole 3D modeling, that would be nice, but that's not the case. With that being said, let's go ahead and actually boot the drone on, hop into the controller, and let me show you exactly how to collect an automated mission with RTK enabled. All right, so let me actually just like walk you through how this entire setup works. Once we're booted on, obviously we've got the controller on. We are connected to the drone itself. We can see our battery here. We can see the network if we are attached to the network, which we should. So if I go here into the information, device settings, network, Wi-Fi, and I am connected to my phone's hotspot. So we are all set there. Let me just keep going back. It is asking to connect to RTK here. So I'm just gonna go and click continue. And just to ensure, we're gonna scroll down here, look at the attachments. There's our PPK RTK, and I wanna do RTK. And this is all of just like my information. So I'm gonna click connect now. And we are now connected. To ensure we're connected, if we go to the radio, we can scroll down. So this is just the signal strength. You can see there is actually a 5G option if I wanted to enable that. I don't have that enabled right now, but it shows our signal strength, what bands we're using if I wanted to switch through, and everything else there. Now, if we go to the fly now, I am set in this like automated capture mode, so we can actually see this 3D scan and the options for apps. If I had other apps, I'd have other ones. Again, that has to go through with, honestly, the whole subscription thing, which, I mean, you already know I'm not really a fan of, but here we go. So if we want to create a map, we can click on the select scan mode. We'll give it a name, so I'll just call this test map. Hit check. Now that we named it, we can actually go and edit our boundary. So this just allows us to do a very simple boundary, as if we're going to do that with any other mapping system. Great. Once I'm done, I can go here and edit the settings. So I can set my launch settings, the overlap, the gimbal pitch. If I want crosshatch, I'll turn that off. If I want perimeter, I can also turn that off. And a few other settings on here. So it's going to fly at 18.5 miles an hour. Now, the one thing that I do recommend turning on is the stop for photo, because this is not a mechanical shutter. So you'll see as soon as I launch the drone, and we'll go to the camera view, it's going to do this like full 360. Just, I want you to watch the motion, not motion blur, but the actual like warping that happens. You'll see exactly what I'm talking about. Once I'm satisfied with all the settings for my map, I'm
gonna just zoom out. I mean, everything is responsive, right? It's a very fast, responsive screen. There's no delay. I have all of my telemetry information that I need here, right? If I want to pop into my camera, here's my main camera. This also has a thermal option too, which I can go in and change the different kinds of color palettes if I wanted to do that, right? There's just a lot of different options on here for the thermal. For the actual camera itself, I have everything just set into auto. So it's gonna just do auto settings. And then I have an option to do JPEG or JPEG DNG, what resolution I want, the camera mode, if I want to throw it in an interval, right? I've got just different options on here, which I like. Anyways, going back to our map here, right? We can go and just continue altering the settings if we want. And once we're satisfied, we click on Begin Scan. And we're just gonna slide. Now, I want you to watch what happens. As soon as the drone goes straight up, just watch this camera view. Everything has this like warping effect. And that's because it doesn't have that mechanical shutter. So now it's gonna execute its actual mission plan here. We can go into the camera view and watch it in real time. We do have an RTK fix because it is telling us that it has a fix. And this exact mission plan here has 60 total photos that it's gonna take. So we can watch in real time where the drone actually is on the map. And then because I set to stop and take a photo at each interval, right, we're actually gonna have a higher output. If I were to turn that option off, the drone would just be flying, I think I had it, 18 miles an hour. So it would just be flying continuous in 18 miles an hour to do its data collection. But again, if you are flying lower because of the actual camera, given that it's not a mechanical shutter, you're gonna have a lot of that warping effect on it. But it's pretty simple, right? So if I were to just let this carry out, it's gonna carry out its entire mission. If I want to stop, I just hit the pause button. If I want to turn back to launch, right, I can do the return back to launch option here. And the drone is just going to autonomously fly back to where it took off. Now, they do have this really interesting mode where it doesn't actually land automatically. It's just going to return back to where it launched. You have to tell the drone to land. So in fact, if I go here on the actual dial, you can see that I have actually not landed at all. So if I want to land, I'm gonna have to manually take over the controls. And I'm just gonna pull the drone back a little bit. Keep going down. And once I'm satisfied with its position, I have to hit this button here and I have to slide to land in place. I'm not actually on the pavement, I was on the sidewalk that you can see there. And then once the scan is done, you can either discard or save it. So pretty self-explanatory here.
So here's the thing. This drone, it does perform pretty well. I'm gonna be fully honest with you. However, they did put out a statement about their connectivity issues. And there were some instances in between showing you just a little flight that I just did now for the automated mission to actually just flying the drone and just letting it do its thing, where there were a little bit of transmission dropouts. Now, given that this does have that 5G capability, it's not enabled on this drone that I have right now, I can see where those transmission issues may be resolved. And it is a good thing that this does have multiple different modes in terms of the connectability between the actual controller itself and the drone and vice versa. But the fact that it's not a super smooth transmission sometimes makes me a little concerned. And there have been others in the industry that have said, yep, sometimes the transmission is just not the best. I think as all US manufacturers, we're just working with a mixed bag of honestly just two manufacturers or really two companies that make the radios for our communication. And we're really just held at the mercy of if they're gonna make it better quality, better integration. I don't know, I genuinely do like this system. I don't like the cost. I do not like the subscription. I do think it's actually built pretty well. Regardless of your feelings about the company in the political sense, what they've accomplished with this system here in a small form factor that it's gonna compete against specifically DJI when it comes to inspection and commercial applications. Again, I am not talking about the search and rescue. That is not my world. And there's others that have stronger opinions about that. I'm not sure if this is the right tool for the job, but it has been proven to be used for certain events that have happened all throughout the US. And there's also a reason why a lot of law enforcement and first responders are using this system. Yes, because of government requirements and whatnot, but that doesn't mean this drone cannot perform, because I think it can, and it has actually demonstrated that it can. So that's just kind of my overall hands-on impressions of it, but let's hop in the studio so I can give you a full kind of wrap up about my opinions about Skydio and really where they're positioned in the US drone manufacturer and capabilities market.
Let me start by addressing what most people in the industry are already thinking about: the perception of Skydio as a US-made option. Skydio sits at a very interesting crossroads. Within the drone community, there are really two major camps: those who completely reject the company and those who support its innovations. A vocal group of users openly refuse to engage with Skydio, often citing distrust or frustration with their past decisions, while others swear by their products and rely on them daily. There's also a more neutral middle ground, professionals who simply treat Skydio as tools, nothing more and nothing less. Skydio's primary focus historically has been within the DFR, or known as Drone as First Responder, and public safety markets, rather than the commercial mapping and industrial sectors that I personally specialize in. However, that gap is slowly closing. The company has been making progress towards expanding into commercial and industrial applications, and I've started seeing more professionals adopting the X10 for specialized tasks, such as surveying, inspections, and 3D modeling. One colleague of mine, for example, uses the X10 for detailed bridge scans, and the results have been genuinely impressive. That's where Skydio's real strength lies: their vision-based autonomy system, powered by the Skydio Autonomy Engine. Anyone who has used it knows how incredibly well it performs in complex environments. Even with divided public sentiment, it's hard to deny that Skydio's engineering team has achieved something remarkable in terms of flight intelligence and its obstacle avoidance. For a hardware standpoint, the X10 is exactly where it should be. For its compact size, there's nothing else like it currently available in the US market. It's not an apples-to-apples comparison against large enterprise systems in the showcase. It's a small form factor drone that performs exceptionally well within its class. When you look at the X10 side by side with foreign-made systems, it holds its own as arguably the best small form factor US manufactured drone available today. In my time with it, everything worked as intended. The camera performance was strong, RTK functioned reliably, and the mapping workflows were pretty much straightforward. There were minor transmission delays, something that actually Skydio made a public statement about, but that's, again, a common challenge across the entire industry. Not something that's too unique to Skydio. But for the price, you'd hope it'd be better. The aircraft flew smooth, with zero disconnects, crashes, or instability. Considering its size, the balance of performance, imaging capability, and robust autonomy is genuinely impressive. Having owned Skydio's earlier S2 model, that you can see behind me here, since launch, and still flying it occasionally today, I can confidently say that the X10 represents a meaningful evolution of their technology. If there was one area where Skydio can improve, it's its perception. The company's reputation is extremely polarized depending on who you talk to. In the commercial and industrial sectors, I've spoken with professionals who hold such strong negative opinions about Skydio that they wouldn't use one, even if it were free. But it's important to recognize that these sectors aren't Skydio's primary customer base. Their business model is largely built around defense, public safety, and first responder programs. Whether they decide to focus more on winning on the commercial market remains to be seen, but it's in an opportunity that I think is worth pursuing for them. Pricing is another ongoing challenge, though it's not an unreasonable one. Component costs, onboard compute, and high-end sensors make these drones expensive to produce. It's not an excuse, that's, again, just the reality of it. Skydio has acknowledged that and has expressed desire to make their systems more affordable and accessible over time. I don't necessarily find the price out of line for what the X10 offers. It's a high-end small drone with serious capabilities, and the costs reflect that. It's worth noting that Skydio's scale gives them a unique advantage within this industry. They are one of the largest US drone manufacturers by production volume, rivaling some major players globally, albeit in a bit of a different market segment. That scale also allows them to maintain tight quality control while ramping up output to meet their demand. Skydio recently hosted its Ascend showcase, where they unveiled 2 new systems that highlight their continued ambition and innovation. Didn't get a chance to go to it, but here's a little bit of the TLDR if you didn't see any of that out in the public. The first is a compact drone built for confined environments, ideal for inspections or tactical operations, while the second is a fixed-wing VTOL, capable of mid-air retrieval via a robotic arm, which I thought was actually pretty cool. Both are highly specialized platforms that target distinct operational niches. While I don't personally have a use case for either one. I respect the technical ambition behind them. More importantly, the company is investing heavily in software improvements that enhance the intelligence and autonomy of their existing systems, especially on the X10 side. These upgrades are aimed at broadening the drone's usability beyond defense and public safety, extending into commercial inspection, surveying, and industrial data collection. Though I do wish it wasn't a subscription model. I wish the tools just kind of came with the drone, but I don't really have much say in that. Looking ahead, I think Skydio's path forward depends on how well they can balance innovation with their outreach. They have the hardware and software to compete. I mean, you can't argue that. It's now about rebuilding community trust and fostering meaningful dialogue with the professional user base. More open engagement, less defensiveness, and a stronger focus on collaboration, I think can go such a long way in mending those relationships across the industry. The hostility and polarization around Skydio have made most of those honest conversations that even I try to have very difficult, and something that I do hope to see change. Personally, I'm not really interested in the politics of all of it. My focus remains on the performance, functionality, and reliability. And in those areas, I still think the X10 delivers, despite some of its shortcomings in some of its other areas, I would say. If I could ask for one improvement, it would be the addition of a mechanical shutter to strengthen its capabilities for high-end precision mapping. But even without it, the X10 is still a very powerful and practical tool. Again, it's compact, efficient, and capable of performing complex missions in environments that would challenge much larger drones. In short, it is a well-built, dependable, and forward-thinking US-made system that's hard not to respect. Overall, I believe Skydio has a strong future ahead if they can continue focusing on transparency, affordability, and most importantly, that community engagement. Their technology does speak for itself, but now it's time to let their actions and the experience of their users redefine how the industry perceives them. For more information about Skydio and the X10 system, check out the link down below. Now let's move on to the next system in the showcase.
Welcome here to the Skyfront manufacturing facility here in the Bay Area of California. I think you guys are in for a treat because some of the stuff that they're doing here is next level, especially for their next level systems. So let me give you guys a little rundown of how all of these systems come to life. And they're actually doing something very unique that I have not seen some of these other companies do within the industry. So let's actually take a look at where the brains of these systems are actually manufactured. So this first area that we're gonna start is where the actual autopilot is built, the actual brains of the system that allow you to operate their massive systems. And something that's really unique, a lot of the other manufacturers or let's say system integrators like to use the Cube Pilot or a PixHawk based board. Yes, these systems still function with the PixHawk system. However, the actual autopilot is their own custom fab. So they manufacture everything all the way down to the chips on the system. This whole rack right here are all the little components that go on the actual boards themselves, which I actually have one of them right here. This is one of the main boards that goes onto the actual autopilot itself. As you can see to my right here, all of the soldering of all the small components and wires happens right here. That is a very unique selling point that Skyfront has built into their actual massive operating drones, is that ability right there, which gives them a whole lot more control that I don't really think a lot of people fully understand, and something we'll talk about a little bit later on within this overview of how Skyfront actually develops and builds these systems on a scale that they're operating on right now. Now moving on to a different area of the actual product assembly for the components, we can see here they have several of the boom arms with their very smart quick connect system that they've actually developed themselves. We'll see that out in the field when we actually fly the Perimeter 8. Is done right here, all the way from the actual arms to the wire assembly to even the motors are done right here. So when we go to the actual final assembly line, which we'll see on the other side of this wall here, everything all comes to life. But yeah, every little component from the actual arms itself to the fuel tanks that are gonna go in and allow for, well, fuel to be injected into the motors is done over here. Every little component, every piece is accounted for. They don't have to go overseas or to another state to get it done. It's done right here. Now, what really makes Skyfront systems special is this guy right here. They have two different options. You can do a full air-cooled two-stroke motor, or you can do a water-cooled. And what they're really known for is long endurance and heavy payload capacity. This is what allows for that to be a reality, as opposed to a lot of the other hybrid competitors that they may have in the market, or even the battery-powered systems. They lack the power that this puts out alongside with their own IP that they've built out in the actual systems themselves. And when it comes to the final actual assembly of the systems themselves, that's what this part of their manufacturing facility is. As you can see, they actually do a lot of integrations. They've done integrations with over 25 different payloads, whether it's LiDAR, a mapping payload, or maybe even this ISR payload that I have right next to me here. And more recently, when Starlink came out with their Starlink Mini, they're doing that integration too. I mean, look at this thing. This ultimately allows for unlimited flexibility when it comes to range. Given that this is a long endurance system, you can fly with a 22-pound payload for up to an hour, or with no payload, or let's say a really lightweight payload, you can fly up to 5 hours. And actually a really fun fact is back in 2021, they have the world record for longest endurance flight of 13 hours and 4 minutes on this exact drone right here. That's absolutely mind-blowing. And they're doing a lot of really cool things with these systems as they have clients all over the world for all different kinds of applications. They're not just pigeonholed into one specific use case. Given that this is just a vehicle that can carry heavy weight, have all kinds of distribution of power, of telemetry, of information. As dumb as this pun sounds, I mean, the sky's the limit when it comes to the integrations and the capabilities of these systems, which I think is why it makes Skyfront such a valuable company in this space, is they've also been around for over 10 years doing these kinds of integrations, doing the R&D, and spending the millions of dollars they've spent in perfecting this system. And again, I don't really think there's another company that can compete with what they've been able to achieve with just how beautifully built these things are. Now, Skyfront doesn't just build long endurance systems. They actually have some cool sensors that they've built out too, like this guy. This is a magnetometer where they've actually done some really cool tests in different parts of the world, can't really say where, of detecting metal objects. You kind of let your imagination play there, but yeah, this was developed by the founder himself, which is absolutely insane. And by also having their own autopilot allows them to vertically integrate just about anything that they want, all the way down to a code level. Something that a lot of integrators can't really say, given that they have to build on top of another architecture. That's not the case here. So you can see there's a lot of versatility when it comes to the kinds of integrations that Skyfront can do, even with their own sensors that they've developed. And another little tidbit that I want to talk about and mention here is, well, they have what's called these buddy drones that they have developed. They've actually had it for a few years now, where it'll basically just be strapped to the bottom of one of their bigger drones. And at any point it can just drop, and now you have a second system that, again, you can kind of leave it up to your imagination. You can follow, you can track, you can do all kinds of things with a second drone. And what's really cool is with, we'll call it the mothership, when this drops off, all the telemetry can pass through, all the video feed can pass through to the mothership that then gets transmitted back to the main controller. Now, this last area that I'm in right now, as you can see, there's a ton of cases. I actually can't fully show you what this station is, but it has to do with the calibration of the actual motors. Given that this is a fuel injected system, whether you go with the air-cooled or the water-cooled system, it's all based off of a custom calibration that they have set. Again, I can't really show you that area, but outside of that, this is where they do all the motor testing, and you can see all the nice big cases for transport. And actually, let me talk a little bit about the transport that I learned a little bit more about. This is one of, if not the only system that comes in a hybrid format that you can travel anywhere in the world and bring the actual components on the plane. Obviously, you have to check it. You can't bring it physically inside of the plane with you, but because of how compact they fold down to, or really break down to, and with a full assembly, if you've been operating them for quite a while, you can fully assemble an entire drone within about 5 minutes. But let's say a 10 to 15 minute setup, especially for what this system can do, I think that's actually phenomenal. Troy, the founder of Skyfront, was actually giving me a few stories of some of the locations that he recently traveled to over the last few months in different parts of the world. He only traveled with 3 cases, and with that ability, you can get anywhere in the world within a day, as opposed to shipping it off with a FedEx or a UPS or a DHL. right? A lot of them have to face the whole battery situation, right? And with what this system is built around and the capabilities that it can support when it comes to the payload side, this is crucial, especially when it needs to be a rapid deployment for some of their customers. So just something that I wanted to note. Yes, these are big cases, but you can bring them on an aircraft with you, obviously as a checked item, but that just speaks to the versatility and with the thought process that went behind actually designing and manufacturing these systems. So now that you've gotten to learn a little bit more about how Skyfront builds its system, from where all the components get manufactured, which is here at their actual facility, to then obviously the entire assembly, integration, depending on what their customers need, why don't we actually go take a look at how this thing operates out in the field, show you how it gets set up, show you the operation of it, and really show you the full capabilities of this actual NDA compliant system. This here is the Perimeter 8, Skyfront's most popular system. And in fact, they've actually been around since 2016 with a quadcopter variant. But this here, this is their pride and joy, and this is what most of their customers are purchasing. And as of recent, you can actually see there is a Starlink on top of it, which has fully embedded C2 communication. With the built-in radios that the Perimeter 8 has, depending on the configuration that you get, you can easily go 30 to 50 kilometers away. And given that it is a hybrid system, something we're gonna learn a little bit more within this part of the video, you can fly comfortably for 4 to 5 hours, which opens up a ton of different possibilities. Yes, mostly this is being used for military and defense applications, but from the world that I come from for data collection, you can strap a LiDAR payload on there and collect a tremendous amount of data very easily. But because of that now C2 integration with the Starlink, something that came about really not that long ago, this can now reach distances that you wouldn't even be able to touch with the Silvus or Doodle Labs radio links that are on here. And what's great is it's able to bounce between both systems, whether you want to use the Starlink satellite for internet connection between your actual ground control system and station and the actual drone itself, or you can use the radio links. So let's learn a little bit more about the system. And what's also cool is this is not just a hybrid drone. You can also operate it entirely off of battery. So I did just mention that you can fly this off of entirely battery. The figures that I gave before of the 4 to 5 hour long endurance flight is entirely off of, well, the two-stroke motor that's in here. Again, something we're gonna learn a little bit more about. There's actually 2 fuel cells that you can embed on here, or you can convert it over to battery power, and you can fly for up to an hour and a half, which is still incredible for a system of this size. So all in, this drone weighs a little bit over 40 pounds, which, I mean, yes, I can easily pick up, but given the actual weight and size of it, the fact that even on battery power, you can get an hour and a half, or with the 2 fuel cells with the motor on it for the hybrid side of it, you can get 4 to 5 hours. That's actually insane. Now, what we're looking at here, this is a standard configuration that most of their customers are going towards as of, I believe, about Q2 of 2025. And that comes with the Silvus radios on here that, again, can get you that 30 to 50 kilometer range, the Starlink integration that is on here, the 2-stroke motor, and the option to bounce between the fuel cells or battery power. And then obviously, depending on what the client's wants and needs are, they can swap out whatever kind of payload they want. They've got a very basic ISR camera setup on here. There are some payloads that they can integrate on here that are going well into the $200,000 to $300,000 range. So just think of this as a very inexpensive helicopter in a sense, but you know, put a few extra props on it and you're gonna get a very capable system that can really achieve any mission that you're after. And so how do you actually control a drone? Well, one of the things that we're looking at here is one of the radios that they have set up. This is a more rugged one for really long range. It can get more compact than this, but you can see they've got the main Silvus radio here with the Starlink on top. That's how you get your full link for going beyond that 30 to 50 kilometers. And then ultimately where this radio link tower plugs into is you actually have two different setups here. If you want a more mobile, agile setup, you can use something like this Toughbook that's right here that will actually run your ground control system. And then you've got this very easy and simple to deploy controller here. Or if you're doing some really long endurance and you have the ability to set up with this shelter that we have here, maybe you've got a van, we've got this awesome computer that's built into this Pelican case alongside with, you know, full camera control over here. And again, this is just for more rugged environments where you're just going to be set up for quite a bit. This one is for more just agile when you're only going to be doing an hour or two flight. You know, it doesn't really matter which one you choose. You have the same functionality between both setups here, just they give you options for that. So I was told that if I bought a drone from Walmart that I would be able to fly it as easily as that. So we're gonna go through that exact process here. Pretty straightforward, especially on this very nice setup here. We're going to start with our throttle all the way down and then simply turn here. Arm. Now, this is gonna be about a 60 to 90 second boot up sequence. Reason being is, well, there's that 2-stroke motor on there. So we need to let it warm up and get to an appropriate one temperature, but RPM, before we can actually take off. Just like starting a car, right? You gotta wait a little bit before you just go. So we'll wait here for, again, 60 to 90 seconds. Everything will prompt us on here so you can actually hear the system talking to me. And then what you'll notice in the top middle of the screen, it just say warming right now. So we'll just wait for that to go to ready. Once it's ready, we can now go ahead and take off. It's as simple as that. Now operating this is actually very easy. It's a little bit different than a traditional controller with, let's say, like a Mode 2. Yep, it is, you know, you can clearly hear the motor, but as soon as we take it some distance away, it starts to get quiet. But I literally just learned how to operate this less than 2 minutes ago before I started recording here. And I already feel very comfortable. Given, well, we're running everything here through the Silvus link right now. We can switch over to the Starlink if we wanted to. And one other thing is this is IP rated. So there is a little bit of drops coming right now. I can actually hear it underneath the tent that I'm at. This system handles it just fine. Now we have full live feed here in the ground control system. It's on the FPV camera. And then I do have the ability to also use the other ISR camera that is on there. This isn't really a super high-end camera, but we do have the ability to move around here. I'm just using this simple little Logitech controller to do so, nothing complex here. And everything is actually labeled, so you know how to actually operate the camera itself. So I can zoom in, I can zoom out, different levels. And yeah, super easy to operate while the drone is still holding its position. So if I want to go back to operating the drone itself, all I gotta do is get back on the sticks. If I want to decrease the altitude, I lower the throttle. If I want to increase the altitude, I increase the throttle. So really, really simple to fly. And one cool thing that you'll notice on the screen recording is with the other payload that is on there, it actually holds its position. So as I was spinning around, now this is probably just a payload specific thing, but I'm just noticing all this stuff in real time. With the right camera that we have, this is the actual front of the camera, or this is the front of the drone. And then on the left side of the screen, that's the payload option that they have integrated with this setup right here. So super easy to operate this system. Like I said, I just learned how to do this 2 minutes ago, and I feel like I can sit here and fly this for the next 4 to 5 hours and one, not get bored, but two, not be stressed out, especially given that a lot of the data that I like to collect is for very large areas, and this would easily handle that without any complications at all.
After having the opportunity to see Skyfront system in person, I have to say it was nothing short of spectacular. What impressed me most wasn't just the flight performance, but their manufacturing capability and just overall engineering approach. Skyfront builds nearly every single component of their actual aircraft in-house, excluding obviously the motors and ESCs, which really showcases an impressive level of precision and ultimately their vertical integration, something that I don't really see that much within the industry. The real highlight for me was their custom-built autopilot, the true brain of the aircraft, paired with the seamless Starlink integration and a remarkable radio communication range. These elements combined reveal ultimately a mastery of both the hardware and the systems engineering that Skyfront has put forth to us. As a hybrid platform, the system is purpose-built for long endurance missions, capable of carrying substantial payloads over extended distances with exceptional reliability, whether that's a LiDAR, a multispectral, a RGB, or even ISR. They all perform very well. And again, the flight performance in the field was outstanding. It was stable, it was very intuitive, and incredibly responsive, even during longer missions, which I didn't get to showcase within this video, but again, that's what the purpose-built is behind for this system. What really surprised me most was how affordable the gas-powered motors were, given the system's overall perceived complexity and durability. Most of the higher cost comes from the payload integration and mission-specific configurations, which does make sense considering the professional-grade focus of this specific platform. While it carries a premium price tag, it's very clear that the Skyfront team is engineered for serious missions where reliability, endurance, and capability are absolute non-negotiables. What I mean about the actual motors is they're a few $100, so you can actually throw really low-quality fuel within it if it's an absolute dire need, and just go and buy a new one, not an entire new system. Skyfront isn't targeting the consumer or entry-level market. This isn't a system for users spending under $20,000 on a drone. Again, their focus is squarely on professional operations and organizations that require very high-performance, mission-critical platforms. In conversations I've had with operators who have used or have worked closely with Skyfront, the ultimate consensus has been overwhelmingly positive. With nearly a decade of experience in this space, the company has refined its craft and built a very deep understanding of what's required for a complex and high-stakes operations. These drones are designed for large-scale missions and projects involving payloads that can exceed over $100,000, including advanced camera systems, LiDAR sensors, or scientific instruments. Every element of these systems reflects a precision, a purpose, and a deep commitment to the reliability, and again, going back on that endurance, given that these drones are made to fly for long periods of time. One of Skyfront's biggest challenges continues to be cost, especially when it comes to the critical components like the radios. In the conversations that I've had with Troy, the company's founder, he did share with me that the radios alone can range between $10,000 and $20,000 per unit. While that may sound steep, these are not really your typical off-the-shelf radios. They're engineered for extreme range, up to 60, 80, and even 100 kilometers away, or 60 miles, which again is crazy. This justifies the price point for the missions that these systems, again, are designed for. The integration of that Starlink does add another level of the operational capability, enabling full command and control far beyond the traditional limits. Despite the rising industry costs, Skyfront has done a remarkable job at maintaining stable pricing without cutting corners. A good testament to their disciplined cost management and their long-term supply chain planning. That said, affordability does remain one of the few hurdles for both the Skyfront and the broader UAV market. The company does continue to explore different ways to reduce cost and make their high-end hybrid platforms accessible to more operators, again, without compromising on the reliability and that long endurance that is defined within their brand. From my own observations, the Skyfront system's combination of endurance, payload capacity, and versatility makes it an ideal solution for high-demand applications. Everything from precision mapping to ISR and scientific research. What's remarkable is how much capability they've managed to deliver in a very compact and agile form factor that can reach environments where manned aircraft can't easily go. Think like helicopters or even fixed-wing planes. I came away genuinely impressed by both the engineering and ultimately the execution. Troy and his team have built something special, a platform that's not just functional but formidable, setting a very high bar in the endurance drone category. Their attention to detail, their focus on performance, and their continued investment in quality and innovation positions Skyfront to remain as a leader in long-range hybrid UAV systems for honestly many years to come. For more information about Skyfront and their platform and really anything else about what Skyfront is doing, as always, go ahead and check that link down below. With that being said, let's go ahead and move on to our next system.
So before Inspired Flight built drones, they were building motors with built-in ESCs. This here is the Brunelli 3. But one of the things that they realized is, well, in order to actually show off these motors themselves, they needed to put them on a system. Now, behind me here, I've got the IF-1200A and their new flagship, the IF-800 Tomcat. We're gonna be looking at some of their older generations in terms of how they got to here, but we are going to be taking a full look at really the full Inspired Flight suite of tools, applications that they have built out, and really showing you how they are supporting the commercial and industrial space as a whole. Now, before we actually go in and do our full facility tour, I want to show you where the roots of Inspired Flight came from. This little, what looks like a high school engineering project was actually one of the very first drones that they built. Obviously, this was not sold. It was more of a testing platform. In terms of the first actual product that was sold, which we took a look at the intro, was the motor that I have right here. And then for the first platform is this IF-750. You can see, very nice, compact, lightweight. We'll call it like a lightweight medium lift payload here. And then here is the IF-1200, which may be a little bit confusing because there's an IF-1200A, but this here was the very first hex system that they actually built. And well, you can see it takes shape and looks very similar to the IF-1200A. This is just their more refined commercial version that exists today. And then now we actually have the IF-800, which is now their newest flagship to be their blue compliant, which this is also a blue compliant drone as well. But this is the one that's supposed to be easy, plug and play, bring it anywhere that you need to get your data collected. But now let's actually go and take a look at their actual full facility to see how these systems, or really these two systems here, are manufactured before it ever lands into a customer's hands. Welcome here to Inspired Flight's full production facility. Now, I am here on the weekend, which is why it is empty, but at any given moment, there could be up to 25 to 30 people in here working on systems. I was having actually a really great conversation with their team leads for about a few hours on the entire process, at where the drone starts its life, to who touches it, to where it gets finalized, tested, before it ever makes it into a customer's hands. And I'm gonna show you every single part of it very shortly here, but as you can see, it's a pretty awesome space in here, and they're actually growing right now. So the way that it looks right now is completely different. They actually transformed this entire facility in about an hour or so before I actually came here. So this is actually a brand new config. But let's take a look at where the life of the drone actually starts. Starting off on this side of the room, over here against this back wall is actually where all of the boom arms get created for the drone. So they actually do all of the assembly here. There's actually two components. There's one off to this side of the camera, and then the assembly line back behind here. And then these two very weird looking tables is where they actually stress test the props. Right here, they'll put the control board for the actual drones themselves. And you can see here's a torn apart IF-800 to also do the same testing. So two different systems here. Again, they're in the middle of a move. They're getting brand new storage containers that will actually put these tables in to do the testing of the actual motors themselves. Now, in this little corner is where the full assemblies happen for the smart batteries for the IF-800. The IF-1200A has basically plug and play batteries, where this one, they have a little bit more complexity to it. So this is an actual casing that you can see. These full assemblies happen right here in this corner. So every single IF-800 battery starts right here. Now, in the middle part of their production facility, where I'm at right now, is where the full assembly happens for the drones themselves. Now, one little fun fact that they were telling me about as I was inquiring about how this whole space works is Not just their brand new drones go through this full process here, but even their RMA drones. So maybe if a drone is having issues, whether it's a motor, a prop, or maybe even something on the logic inside, it all goes through here. That way they have a standardized process. And what's also really cool, in every single one of these desks, they have full manuals. So here's one for the IF1200, and here is one for the IF800. This is the full core assembly of both systems. And there's a lot of documentation in here. So they really have a very thorough process when it comes to assembling these drones. This guy right here is actually 3 years old. They were showing me one of the serial numbers on here, and it's just getting some basic upgrades from the customer. This thing has just been running for hundreds of hours. It's back here in the shop, getting some upgrades. The one behind it is actually their brand new latest version of the IF1200A. But yeah, every single system, right now this one's configured to assemble IF1200s, but at any point they could switch over production to do the IF800s. And to continue that theme of their processes, we have an entire QC, IPQC, and even a full QC of every single component that actually goes into the drone. So they're not just getting everything, throwing it onto the drone and shipping it out. They're really going through the full process to make sure that every single customer that receives a system has gone through an entire protocol before it ever lands in their hands. And as for this back area that I'm at, it's engineer land. You can tell by this really funny sign, is where all of the final testing happens to make sure all of the components on the drones are working properly. I've got 3 full desk setups here, but there's actually an area that I want to show you where the engineers like to do a lot of their testing for either custom configurations or maybe top secret projects that I might be able to show you a little bit about. But right here is where they live, but they have a few other areas that they like to do testing, whether they're doing custom configurations for payloads for specific clients, or maybe they're going through a software iteration with the software dev team. So let's go check that area out. Now, this room that I'm in is one of their R&D and engineering labs. I can't show what's going on right here because I had to sign an NDA before I even walked into the building for this specific area. Everywhere else that I'm showing you has nothing to do with the NDA, but they have a really cool partnership that they're probably going to announce Q1, Q2 of next year. But in here, they're doing very cool testing of integrations of custom components. And that's actually one of the cool things about Inspired Flight is depending on the customers and their specific needs, they have these different facilities here tailored specifically for those kinds of integrations. And this is the second R&D facility that they have. This is actually a very custom bench that they built out. As you can see, they actually have a lot of control boards for the actual drones themselves. This one over here happens to be for the IF800, and the one closest to me happens to be for the IF1200A, where they're testing different payload configurations. So in this case, they have the smart dovetail mount. This is so that if, let's say, a customer wants a very specific payload integration, well, they have this testing facility that you have right here. Not only do they test different payloads, but maybe different control systems that they're trying to integrate. Different video feeds, different telemetry, different radios can all be done right here. And yeah, there's a lot of stuff going on in this room that I also can't show, of different components, different payloads that they're trying for some of their clients. But yeah, this is the second R&D and really engineering lab that they have here at the Inspired Flight facility. And finally, for one of the last rooms that I'm going to show you guys here, there's a few other admin offices and customer support. There's just a bunch of desks with computers, nothing really that interesting, is the software development team. Now, one thing that I won't be necessarily talking about out in the field, but we'll actually be taking a look at one of the 2 software that they have built out, is Inspired Ground Control, which Inspired Ground Control is the way that you actually control the systems themselves, whether it's the IF800 or the IF1200A. They both go through their ground control system called IGC, and with that allows you to do all your mission planning, the maintenance of the vehicles themselves, as well as a bunch of other things that they're building out. And then the other software that they're putting a lot of R&D into is called their Elevate platform. In the future, it will allow for full fleet management. So a fleet manager will be able to see every single system in the fleet, be able to push maintenance, be able to basically assign certain systems to certain pilots, to do mission planning, to do a whole suite of operations from their Elevate platform. And ultimately, in about 12 months from now, not sure how much I can talk about it, but they will have a brand new ground control system that they are fully building out themselves that completely bypasses what most people think is just a reskin of Q ground control, when in reality, this entire 5-man dev team is what has been behind the brains of not just the actual functionality of the drones themselves, but also the integration piece, right? So they actually work very tightly with engineering and R&D to make all of these systems talk together. Now that I get to see where these systems come to life, let's actually take it out here into the field and show you how they actually operate, alongside with some of the newer innovations that I think I'm one of the first people in the industry outside of the actual employees themselves that get to fly the new setup, which I'm actually very excited and get to show you some of the innovations that they've added into it. But yeah, obviously we've got the IF-1200A here on my left-hand side, and then the IF-800 Tomcat, which is their newest flagship that they've had. They've actually been selling it for the last year or so, but they've made a lot of improvements to the software and even some of the hardware components to really make it a super capable system of delivering data collection at ease. We'll be flying the IF-800, but I did want to talk about the IF-1200A, as this has been a system that has been in the market for about 3 years now. We actually got to see one of the original setups of it, one of their original customers that actually had one of their systems in for just some tune-up, and it was from 3 years ago when they released it. But yeah, this is their medium heavy lift option. So if you're carrying a heavier LiDAR load, or maybe you're doing some multispectral data collection, or just need a system that can carry some weight, this is the guy for you. Now, for most of you that are gonna be doing a lot more data collection, a lot of automated data collection for, let's say, photogrammetry, or even some of the lighter LiDAR payloads, you've got this guy right here. But let me take you through a full unboxing setup and actually throwing this up into the air, giving you my honest impressions about how the system flies and how it actually functions for automated data collection. So let me walk you through setting up the IF-800 Tomcat. Really simple. You get this nice hard case for transport. Opening it up, you'll notice you've got the drone right here. You've got your landing gears, and then whatever payload you opt for this drone, whether it's a mapping camera, a LiDAR payload, or maybe an IR or thermal payload, you have that foam cut insert. This looks a little bit different compared to what you'll actually get. And then if I take this foam out here, you'll have the spot for your controller. In this case, it's the new GS1. So really compact, really easy to transport the entire system anywhere you need to go. But then putting it together, very simple. You just take your landing gears out here. There's a little pin that'll lock it into place. When you first insert it, you'll hear the click, and then simply just pull it out, flip it over. Let me make some room on here, place it down, and then we can get our props out. What's really cool about these arms here is it has a built-in auto locking mechanism. Now, you still have to fully lock it into place, but it's just in case if you're going through it quickly, which you probably shouldn't. When you throw the arms on, it locks into place slightly so that if you do take it off, it's still in place and doesn't move. But of course, you want to make sure that you lock it in place and you have the orange line up with each other. And it's the same for every single arm. So it's a great safety feature that they built into this system here. And then with your payload, they have a nice dovetail mount here. So super easy to get your payload in. Here's a nice little lock. And then we'll finally fully lock it into place here. And then all that's left is to actually get your batteries into the drone. Now, before you actually put the batteries in, there's a little button you press on the back to wake the batteries up. And then once they're warmed up, we can go ahead and slide them into their trays. Make sure that you lock it on the back. You're pretty much ready to go. So all that's left is to actually boot on the controller. And if you're doing an automated mission, to either preload your automated mission, whether you do that in the office, or you can even do it live in the field, because one of the features of the GS1 is it does have an LTE connection into it. So you don't have to do all your mission planning at the office. Let's say maybe you need to make some tweaks out in the field because, well, that's probably something that you may have to do. Now let me take you through a full run through of getting the system up and running, and even planning a mission here on their IGC, which is their version of their ground control system, which actually functions very well. I did some play testing with it the day before filming this, but very intuitive, like super easy to punch through what you need, be able to get the parameters in. And rather than telling you, let me actually show you. First, obviously we need to boot the drone on. So I'm just gonna press the button on the back. already got our controller booted up, but we'll wait for it to go through its boot sequence. And as we start to get full tele and video feed, we can see it populating here on the screen. Now, given that this is a dual battery setup, there's actually dual GNSS antennas in there as well. So there's a lot of redundancy built into the system, which I think as a power user like myself, it makes me feel a lot more comfortable being out in the field as opposed to just a single solution or single option for GNSS and batteries. There's a lot of power built into this system. And I think you guys are going to recognize that once we get it up into the air. But here we are. We are already in the IGC. Looking at the feed here, this is actually the main FPV camera, which me as a pilot who sometimes flies a little bit lower, depending on the data collection that I'm doing, I like having that. It just gives me more situational awareness while I'm operating the system. But to switch over to the other camera, again, the one thing that I am actually very happy to actually see and play with is the integrations that Inspired Flight has done. This is the ILX LR1, so it's that 61 megapixel from Sony. Everything functions on here the way that you need it to function. And you also notice that with some of the other payloads that they have. Given I primarily focus on the photogrammetry side of things, I don't do a lot of stuff with thermals, so I'm not gonna touch on that, but because they have that smart dovetail mount that's built into it, the integration is probably one of the key features that you will notice that their systems have implemented. Not a lot of other competitors can say the same. Even though this is not supposed to be a comparison, that is just something that I do want to note, getting hands-on with all these different systems here. But to switch over to the other camera, I just have to press the 1 on the bottom right-hand corner, and there we are. We are now on to the actual Sony, and the rockers, the rockers on the controller actually change everything on here. So we can see as I tilt up, so does the camera, it tilts up. And if I want to rock to the left or to the right, I can also do that as well. Now, one thing that they are working on, given I am on a very beta version of this before it actually fully gets released, is the latency. They are working on that. And that is actually one thing a lot of the US manufacturers have issues with, is the tele. And it has to do with the radios. I think we're all pretty familiar with the instant feedback that the Chinese competitors have. That's because, well, we are not allowed to use that when it comes to the NDA side of things. So something they are still fine-tuning, something that their dev team is going through every single day to get it snappier and just more responsive, which, you know, if you're doing a lot of inspection work, that may be a concern for you. But for me, where I do a lot of mapping, I just need the system to operate in collecting high quality data, which for most people, that's gonna be more than okay. Now looking on here, I can actually go ahead and pop up our actual map. So this controller actually has LTE built into it. So you don't really have to worry about running around with a hotspot on your phone or maybe a mobile hotspot puck. It's got this built in, so you can load full res satellite map anywhere you are. And you can see I'm right here on the coast. And actually, let's go ahead and plan our mission. So on here, we're gonna click on the fly and we're gonna do a survey. So it already created a takeoff point. We can change our altitude here. I don't know, let's say we're gonna fly 60 meters from this takeoff point. Now let's give it a survey pattern and we'll just click on this basic and then we'll pretty much just draw the area that we want to fly. So I'm gonna fly over this open field just behind me here. We can also put our altitude on this too. And then all that's left to do is make sure that our return to launch is back where we take off. From there, all we need to do is hit the upload plan. So this is gonna upload all those waypoints to the drone itself. And now it's as simple as going over to the fly page and we can see that we can just take straight off from the ground. So let's throw this up in the air and collect some data. As you can see, they made everything really simple to operate, from turning the drone on to making sure that everything is actually properly working, to now the drone is already going to its waypoint from a simple swipe of the screen. And you'll probably notice in the bottom left-hand corner, we actually have our video feed. So this is directly off of the Sony that we can see. Maybe I want to switch over to the FPV mode. All I got to do is just hit the number in the bottom right-hand corner and we've already switched over. Switching back over to the Sony camera, it's already triggering. What's great is that because of the tight integration, they're actually getting all the geotagging happening in pretty much real time that we don't have to do this after the fact. But as you can see, the one thing that I did talk about a little bit earlier was the video feed, where it has a little bit of a latency. Given that this is fully automated, I'm just using this screen right here to make sure that it's looking where it's supposed to be looking. And well, I can confirm that it is, but again, just something to note there. And just like that, we have completed our mission plan here. So now it's automatically returning back home. And let me talk a little bit about the battery life. This was only a few minute mission, but with this exact payload right here, you're comfortably getting about 35 to 37 minutes of flight time, even with some decent wind speed. So here it is, coming back down. And one nice thing is, as soon as the drone lands, it automatically disarms the entire thing. So they built in a lot of safety features into this system here, and this also carries over to the IF-1200A too. So you can fly with confidence with this system, and with confidence I did fly. I mean, this thing was so easy, as you saw, not really much that I had to do. When you're done, it's gonna ask what we wanna do with our flight plan. It's as simple as remove from vehicle, and there we go. So even with that short flight that I flew, we still have 89% battery life on this system right here.
To be fully transparent, I went into this showcase with a bit of bias. I had heard some mixed comments from colleagues in the industry, and I'll admit it did influence my initial expectations. But I was genuinely taken aback by what I experienced. The Inspired Flight team completely exceeded my expectations, not just in their professionalism and attention to detail, but in the engineering sophistication behind their platforms. My overall impression of Inspired Flight absolutely blew me away, especially because of their ingenuity in payload integration, which is something that I do care deeply about, given I am collecting lots of data for all kinds of clients with all kinds of sensors. My real-world flights with the IF-1200A and IF-800 were nothing short of impressive. The system felt stable, reliable, and capable. There's reasons why customers are still flying the IF-1200A platform 3 years later with consistent results. Going behind the scenes gave me an entirely new perspective on the company itself. What stood out most was the team's energy and passion. These aren't just engineers. They're people who truly care about advancing UAV industry. I mean, you can see it in the way they continuously iterate, troubleshoot, and improve with every hardware and software update. That dedication has led to a much more refined product in the IF-800 line, which has seen significant improvements since its debut about 2 years ago. Earlier versions of the IF-800 did face some criticisms from users who felt the platform wasn't fully mature, especially in terms of integration and consistency. A local surveying firm I spoke with here in Florida mentioned that they initially purchased the IF-800 because they needed a Blue UAS system approved for government contracts, even though they were aware of early concerns. That highlights one of Inspired Flight's biggest early challenges: its perception. From what I've seen firsthand with the latest iteration, however, it's clear that many of those initial issues have been addressed. The system feels solid and far more complete, though I know the team is still refining performance and integration across payload types. Within the professional drone community, optimism around Inspired Flight is growing fast. The IF-800 is proving itself as a legitimate US manufactured option for operators looking to transition away from those Chinese systems. The company is becoming more transparent and active with community engagement, and it's also helping reshape their public perception, a crucial step in earning long-term trust within the industry. When it came to the hands-on testing, I was running an early beta version of their proprietary ground control software. It literally shipped to me 8 hours before my arrival. Despite that, flight control was completely normal and stable. The only issues that I encountered were some noticeable camera and video delays, which is a common issue with new firmware builds, and it's something that's easily fixable through updates. For a software platform that is still in active development, that's a small hurdle and one that's already being worked out. Now, one of the smartest decisions that I feel Inspired Flight has made, again, in my opinion, is adopting the Freefly Smart Dovetail mount for their payload integrations. This is an open source format that really Freefly released out there for anybody to use. And so the fact that Inspired Flight is using it, I think it provides a strong mechanical interface and dramatically simplifies an entire integration process, which is an area that many manufacturers struggle with. That single decision choice helps eliminate one of the biggest bottlenecks in the professional drone development, which is ensuring that payloads communicate seamlessly with the aircraft's onboard systems. Whether it's a camera, a LiDAR, a gimbal, it all just works practically seamless. Again, it's an elegant and practical solution that speaks to Inspired Flight's engineering mindset. From a pricing standpoint, these systems are not cheap, but that is to be expected. Like every US manufacturer, Inspired Flight faces similar cost pressures around sourcing high-end radios, flight controllers, and the electrical components that aren't fabricated here domestically. The pricing reflects that reality. What is encouraging, though, is that Inspired Flight is actively expanding its production infrastructure to increase output and drive efficiency, which will eventually help offset some of those costs. During my visit, it was clear that Inspired Flight is scaling aggressively and intentionally. They've made substantial investments in both their manufacturing capability, adding both production space and personnel to meet that growing demand. The recent funding round has also allowed them to expand on their software and integration teams, all critical areas that will help refine the ground control system, streamline the payload compatibility, and elevate the overall reliability. Beyond that, they've also established a number of strategic partnerships, some not yet public, that are focused on strengthening interoperability and the long-term support of everything that they're providing to this industry. Those relationships tell me that the company is thinking far ahead, building a foundation for sustainable growth, rather than just those short-term gains. To be honest, what impressed me the most wasn't just their technology, it was the culture. Inside their engineering and leadership teams, there's an obvious sense of purpose. There are people who genuinely believe in what they're building. They're not simply just producing another drone. They're creating what they want to be one of the highest quality and most trusted platforms in the US market. Many of their team members bring serious technical backgrounds and deep industry experience, which shows in how polished their systems have become. You can absolutely feel that conviction across every single department there. I strongly believe in the mission that Inspired Flight is pursuing, to develop a top-tier platform for mapping, LiDAR, and really any commercial application that these systems are going to be used within. The IF800 is already a capable, well-engineered system, and with continued refinement, it will evolve into an even more dependable workhorse for professional operators, just like its older brother, the IF1200A. Again, their foundation is solid, the design is thoughtful, and the intent behind their production is clear: to offer reliable, US-made Blue SUAS platforms that can carry high-valuable payloads safely and efficiently to get the job done. From both a technical and a business perspective, this is a system that I would personally invest into. It represents a practical bridge for organizations transitioning away from those Chinese manufactured drones to compliant American-built alternatives. I know that transition isn't necessarily easy for everybody, but it is an important one, and companies like Inspired Flight are making that possible. Their commitment to the quality, the transparency, and again, their continuous innovation left a very strong impression on me. I genuinely believe that Inspired Flight is positioned to capture a meaningful share of the US commercial and government drone market. The vision and drive behind this team aren't just about keeping pace with the industry, they're helping define where it ultimately goes next. More information about Inspired Flight and their systems can be found in the link down below. With that, let's go ahead and move on to the next system in this showcase.
When you hear the name Wispr Systems, you might think of advanced aerial platforms and high-end data collection tools. But the story starts far more humbly, on the ground in this Mississippi heat here. Connor, one of Wispr's founders, grew up working alongside his dad, who was one of the early integrators of wireless internet service here in the state of Mississippi. They spent long days setting up towers and antennas for wireless internet service providers. Picture this, up in a bucket truck, holding a dish, hunting for a signal that could take over an hour to do. It was grueling work, and Connor knew that there had to be a better way to do this. That's when the idea struck. What if a drone could do this job in minutes as opposed to hours? Connor began experimenting with drones equipped with antennas, cutting a 1-hour job down to just minutes of flight time. He wasn't working alone for long. Austin, a lifelong friend, soon joined the effort. Then came Carl, a fellow Mississippi State student Connor met while coding together on campus. The big break came in 2015, when their college professor received a $20,000 grant for a project in measuring soil moisture, and they decided to do this with a drone. Connor, being the mastermind of all of this, built 3 different drone systems that can make this happen. The university hosted a Shark Tank style pitch competition, and the team's concept won funding. In 2017, Wispr Systems was officially born, with Connor and Austin leading the charge. The company's early focus was on the WISP space, known as the wireless internet service providers, hence where Wispr came into play here. But as their technology matured, they began working with experts in the AEC and surveying industries. They learned what those professionals needed most: drones specifically designed for data collection with the flexibility to adapt to unique workflows. By 2020, Wispr had a breakthrough: the Ranger Pro, the drone that started it all. The Ranger Pro was built to be one of the most versatile aerial platforms in its class. It could carry payloads up to 7 pounds with plug-and-play ports on the front so that customers could integrate the tools that they needed most, without the complicated modifications. Wispr partnered directly with major payload manufacturers like Sony and Inertia Labs, ensuring tight integration with the Ranger Pro. They also worked closely with Gremsy, making camera and gimbal setups seamless for users. The Ranger Pro wasn't just another drone. It was a system that could be tailored to each customer's mission and their tailored data collection needs. Fast forward to 2024, and Wispr took another big leap forward with the release of the Sky Scout. This compact, changeable payload drone was designed with a unique philosophy. Mission planning should start with the payload. Instead of trying to force third-party software to work, Wispr built its own mission planning tools from the ground up, based on the sensors that the drone was going to carry. And to ensure that customers can make the most of their investment, Wispr also introduced Wispr U, which is their online training portal that covers everything on how to operate the actual system itself, to mission planning, and even payload execution. Now, here in 2025, Wispr is rolling out their new Sky Scout 2.0, which is just a more refined, a more capable version of this unit that we have right here. Now, before I show you how easy and simple it is to actually operate the Sky Scout, let's take a look at where all of these systems are born. We're first gonna go take a look at their manufacturing facility that is here in Mississippi, and then we'll take a look at their QA and QC process to ensure that any customer that receives, whether it's the Ranger Pro or the Sky Scout 2.0, it's up and operational. And in fact, they're actually doing testing right behind the camera here. And this here is where Wispr Systems manufactures their system. They've actually partnered up with a contract manufacturer called CM Solutions. They're based here in Corinth, Mississippi, about an hour and a half to 2 hours away from Wispr Systems' main headquarters. But again, this is where everything is manufactured. Any system that you buy from Wispr Systems is here. And behind me here, you can kind of see there's some action going on, but this is where it all starts. But let me take you to where all of the little components are for the actual Wispr Systems themselves. This wall of parts here is every single component that goes into your Wispr Sky Scout. I mean, take a look at this. Here is your actual motor arms, as well as motors for, well, the props that actually fly the drone right here, as well as the actual body plates that, well, the system is fully built around. And so everything that is needed to build the Wispr Sky Scout, as well as the Ranger, is in this booklet right here. So when the Wispr System team says that their systems are built here in America, they really are built here in America. And I've been fortunate enough to be able to actually see the entire process behind the scenes. Now, from the manufacturing, we make it back here to the main Wispr Systems headquarters, where all of the QA and QC is done before the system actually makes it out to their customers. So all the final touches here, all the final gimbal integrations, payload integrations happens here, and they actually do all the flight test right behind me, which is actually we're about to go and do a full flight test showing you how easy it is to get set up from opening the box, putting the system together, throwing a payload on, mission planning, and data collection. It's flawless. So let's actually go take a look at that. But as you can see, everything is finalized here before it gets shipped out. So obviously having an operational system is important, but before you actually get out to the site, you need to transport everything. And with how small, how light, and how portable the Wispr Sky Scout is, honestly, like I was genuinely surprised at how compact this entire package is. Right now, we're actually taking a look at what you get with the full hard case that comes with your system. So opening up, we actually have our drone right here, 1 set of batteries, 2 set of batteries, your battery charger, cables, extra prop, your landing gears, and then everything just folds nicely into here. We also have their new controller with a 2000 nit screen, super nice joysticks, and dual rockers for tilting the gimbal up and down and moving it to the left and right. So honestly, a very nice, hard package that is coming with their new SkyScout 2.0. Very compact, very easy to transport, and something not a lot of, I think, other manufacturers can proudly say here. Now, one more thing before we actually throw the drone up in the air, I wanna talk about how easy they made it to pop out different payloads. Right now we have the Sony ILX LR1 61 megapixel camera, but you also have an option for a thermal, the VO from Gremsy, or the M2X. This is the very beautiful LiDAR sensor from Inertial Labs. And with their direct integration and basically custom gimbal setup that they work with Gremsy, it's as simple as twisting here, getting your other payload, popping it in, and locking back in place. So, I mean, it's really easy to use and maybe very familiar with one of the more popular brands in the space, but that was the entire idea. They didn't want there to be a lot of clunkiness and friction when it comes to swapping out payloads, because they know that operators need a very simplified solution to get up and in the air as quick as possible, whether they're doing photogrammetry or they're doing LiDAR or even thermal. And they also have some other payloads becoming available here soon. Even my time here, they made a few new connections with some other payload manufacturers to get it directly integrated onto the SkyScout, because the SkyScout can support up to 1.6 kilos, which gives you actually a lot of flexibility when it comes to payloads in this class right here. So for full operation of this system, once you get your arms folded out, your legs on, and your payload onto the drone, honestly, it takes less than 60 seconds to get that all set up. We're gonna go ahead and just place it on the ground right here. I'm gonna just spread my props out here. And then finally, we'll get the batteries. Now, these are smart batteries, very similar to, again, another popular brand you might recognize, but they do show you battery status. So if I press on it here, maybe a little hard to see with the super bright sun, but as soon as you insert it into the drone, it is automatically gonna power on. This also does have hot swap capability, which I know is a feature that a lot of system integrators try to integrate, but isn't always easy to do. So as soon as we put this in, we'll get both batteries here. All right, and once we are booted into the drone itself, one thing that I do really want to mention here that made me very, very happy with this system is RTK works. So I'm actually connected to an Ntrip network. For those of you who don't understand how important this is, specifically when it comes to a mapping system like this, it is a game changer. And there's really only a few players in the market that make it super simple. I didn't even know that this is how they were actually able to get it work. And to prove that, if we take a look in the top right-hand corner, we can see we have an RTK fix. And I can even show you, if I go here into our settings, which you can see how intuitive this interface is. I'm on the GNSS settings here, and here is the RTK. And I'm not gonna show all the settings here because it's not my account, it's theirs, but here we are. We already have RTK enabled, and we have an RTK fix. Now, how do we actually plan a mission and get data collected? Well, here on our just main viewer, all we have to do is click on the Wispr Systems logo in the top left-hand corner. We're gonna click on mission planning, and here we'll click on takeoff, then we'll click on a pattern. So we'll do a survey, and we can either do a basic pattern or load a KML. We'll just do a basic pattern here. I'm gonna make this really small because we don't really need to do too much here, just for this demo. And we're done with the polygon. We'll have a 70-70, 250-foot altitude, great. And then from there, we will click a return. So now the drone will take off, fly its mission, and return, all while flying with RTK tagging. So let me just move this table back a little bit to give the drone a little bit more space to take off. Okay, and then all we have to do is just click on the upload to vehicle button in the top right-hand corner. Beautiful, then we just click on the Wispr button again. We go back to our main screen, and then all we have to do is just swipe to confirm or start the mission. So now that we sent the drone off, we're just gonna let it get to its first waypoint and do what a system like this is programmed to do. We can notice in the top right-hand corner, we do have that RTK fix, right? That is one of those critical features that systems of this class should have as the bare minimum. And they have it working, something that I haven't really seen a lot of these other system integrators do. again, this is not necessarily a comparison, this is more of a showcase of this drone right here, but something I do want to call out here. So once the drone gets to its first waypoint here, there we go. Camera goes straight down to a nadir position, and now we're autonomously gathering data with that Sony, with the gimbal and the drone and RTK all in one. But as you can see, it was super easy to get that entire process done. Now, let me give you some of my overall final thoughts about the Sky Scout and Wispr systems as a whole, what I learned about their company, and really what they're trying to provide to this industry.
It's clear the Wispr team listened carefully to community feedback from the first generation and implemented meaningful upgrades that elevate the entire platform. What struck me immediately was how compact and well integrated the system is. So many core features are built directly into the aircraft without no external modules or clunky add-ons. The manufacturing quality feels solid and aligned with where Wispr is positioning itself in the US drone market. But what impressed me most was how intuitive the aircraft was to operate. I went into this test with a fair amount of skepticism based on earlier perceptions of Wispr systems, but that skepticism disappeared pretty quickly. Without any formal walkthrough or prior instruction, I was able to power on the aircraft, connect the controller, and launch the drone effortlessly. Everything worked exactly as it should, especially that RTK connection. And that kind of reliability and simplicity is incredibly promising for an American-made platform. In conversations with operators who own Wispr systems, especially the Ranger, which falls into the medium lift category, the feedback was consistently positive. Those aircraft can carry heavier payloads, while the Sky Scout 2 Plus sits in a sweet spot between portability and compatibility. It can comfortably handle RGB and LiDAR payloads, making it ideal for mapping and data collection workflows without being overly bulky. Most Wispr users I spoke with described this system as reliable, functional, and purpose-built. They might not be the most visually refined drones on the market, but where they lack in aesthetic polish, they make up in performance. That aligns perfectly with what I saw firsthand, a solid, capable machine that just works. As with most US manufacturers, Wispr system does face some hurdles. From what I've observed and discussed with their team, their biggest challenges center around software refinement, manufacturing scalability, and component sourcing. And again, also overall market visibility. On the software side, they know it's not perfect yet. My personal experience felt smooth and intuitive, but they acknowledge that they need to continue refining their proprietary ground control experience to better represent their identity as a US manufacturer. Manufacturing scalability is another priority. Right now, production capacity sits at around 200 to 300 systems per month. The goal is to scale to 500 or even 1,000 units to keep up with projected demand. And like every company in the space, component availability remains a frustrating industry-wide bottleneck. Wispr recently secured a significant round of funding, and they're using it wisely. A large portion of that investment is going into strengthening their software ecosystem, something they've recognized as both a challenge and an opportunity. Their aim is to refine the overall user experience, build a more cohesive and integrated ground control platform, and deliver a system that feels more unified for commercial and industrial operators. They're also investing in scaling up manufacturing and expanding their partnerships across the payload ecosystem. Wispr already integrates seamlessly with major players like Remzi, Inertia Labs, and Sony. And those integrations perform better than I honestly expected from a company of their size. As they continue to expand their compatible payload lineup, LiDAR, RGB, thermal, and beyond, they are really positioning themselves as not just a hardware manufacturer, but as a solutions provider. What stands out most is the team's commitment to long-term growth, innovation, and supporting the broader ecosystem. They've invested heavily in R&D, improving performance across the board, and making thoughtful decisions that contribute to a sustainable future for their product line. Their growing financial backing, technical partnerships, and culture of iteration place them firmly on track to become a major force in the US commercial drone market. Overall, I believe the Wispr Sky Scout 2 Plus is positioned incredibly well to become a leading contender in the commercial and industrial data collection space. As someone who regularly performs RGB and LiDAR mapping, the integration stood out immediately. They're near flawless, and everything communicates with the aircraft the way it should. The highlight for me was the RTK performance. It just worked. No troubleshooting, no guessing, no wasted time. For professionals who rely on precise, high-accurate workflows, that reliability is a massive win and shows that Wispr understands exactly what modern operators need. RTK reliability has become a must-have in this industry, and I believe that Wispr absolutely nailed it. Again, I believe that Wispr has created a tool that cuts through the noise and delivers where it counts. It's a strong, trustworthy option for any operator focused on real data, real missions, and really real results. More information about Wispr systems in the link below. Let's now move on to the next system in the showcase.
So there's a saying here in Texas, everything is bigger in Texas. Well, Hylio's flagship Ares HYL150 doesn't just live up to that slogan, this thing embodies it. Built just outside of Houston, this American agricultural powerhouse weighs in at about 110 pounds and can carry up to 14 gallons or just under 50 liters of chemicals for spraying applications. One of my favorite design choices is that it's a quadcopter, not a coaxial setup like many of the other larger ag drones. This means it runs on a single 18S 30-amp battery, keeping operations simpler, lighter, and more efficient in the field. With a 20 kilowatt-hour generator, you can fast charge 2 batteries back to 100% within about 10 minutes. At peak performance, the HYL150 can cover up to 70 acres per hour at a 2 gallon per acre flow rate. For the spray systems, you get flexibility. You can either opt for a hydraulic nozzle capable of delivering up to 4 gallons per minute, or choose a rotary atomizer that lets you adjust droplet size anywhere from 35 microns, which is like a fine mist, to 500 microns, which simulates larger droplets. This flexibility allows you to match droplet size to the specific chemicals and application needs, something I think should be standard for drones of this class. This model is also a major milestone for Hylio, as it's their first fully in-house design and the 5th system they've brought to market with over a decade of innovation. It's not just for spraying either. The system can be outfitted with a spreader attachment that carries up to 20 pounds and can spread at a rate of 25 pounds per minute. Of course, looking impressive is one thing, but performing in the field is another. Setting up this system can be done with just one person. Once you put it in place, all you need to do is pop the little bungee cord protecting the props out, pull it up, lock it in place, spread your props, then get your battery, place it in, and then finally fill your tank up. Something you can do within 60 seconds, to be honest. The ease of use is no accident either. Hylio's founders began as service providers in Costa Rica between 2017 and 2019, spraying tens of thousands of acres with their own modified designs. Every frustration and pain point they've experienced in the field has been addressed in this model. From what I've seen today, the workflow is so intuitive that I could confidently operate it myself after just 15 minutes of hands-on time. Now, flying is a fully automated process. From takeoff to application, return to home for refills, everything I saw ran smoothly. The real magic lies in the software. And Hylio has its own developed software called Agrasol ground control system, running on a very rugged Windows-powered controller. Look at this thing. Agrasol can calculate the precise amount of chemicals required for each field, configure nozzle or spreader behavior, and even generate ortho maps directly in the field for accurate mission planning. It also produces real-time reports for EPA and FAA compliance, making it easy to provide documentation on demand to both clients and regulatory bodies. One of the most powerful features is its swarm capability, allowing a single operator to control up to 3 drones at once without juggling multiple controllers. This boosts efficiency, shortens turnaround times between battery swaps, and ultimately maximizes daily revenue potential while keeping clients happy. What stands out most to me is the responsiveness of Agrasol. Too many ground control systems suffer from laggy, frustrating interfaces, but that's not the case here. What I personally wouldn't mind is a controller about half the size, but the trade-offs make sense given the processing power needed to run a system with really this many features. Now, as much as I'd like to stay out here and keep spraying, why don't we head back to Hylio's HQ and check out where all of these systems come to life, as well as see their other systems in the lineup. Welcome to Hylio's main 40,000 square foot manufacturing facility. To the right of me here, I have the AG230. This side of the room that I'm currently on is where all the final touches get put onto the systems. Behind me here, the systems that we're just looking at out in the field, their Ares HYL150s are getting their final touches, as you can see. But what's really cool is they actually design, fab, install, and make sure all the systems are ready to go right here. It's not done somewhere else. It's all done here with, actually they have quite a lot of employees, although I'm here at 5 o'clock, so the day just wrapped up. But let me show you around at really how these systems come to life. So where I'm at right now, this is where all of the repairs get done, or even services or upgrades, whatever their customers need, they're here to support them. But given that they are also in the ag field, they do a lot of remote support so that the systems can get back up and running. But if there's maybe a major component release or something critical happens, customers are able to ship it back here to their facility where they can get fixed. As you can see, these big ones that I have behind me here, these are the AG272s. There's another AG230 right next to me here. But yeah, everything you can see behind me, they have people dedicated to helping their customers get back up in the air, get their newest upgrades. It's all done here. Now, just behind the repair area, this is where they have all of their pre-assembly. So making sure all of the little components are put together, making sure that they're fitted, that they're test fitted, and ultimately ready to go back to where we actually had just started the initial tour for the final assembly. But yeah, all the little components that you see on their systems, whether it's the nozzles, the spreaders, it's all done right here. Okay, remember the big ground control system that we were looking at out in the field? Well, they are actually hand built here. I think you can kind of see the theme here. Hylio takes pride in all of the components that they manufacture, not just the drone, but also the control system itself. It's all custom made right here. Now, something that I did mention is that Hylio is on their 5th generation system, or actually their newest generation, that's the Aries, and then they have their original generation, which is their AG line. Now, the AG line has actually had an entire generational change. So when they first came out with systems, it was titled something like AG-116, but now they are on the Gen 2. So it's AG-210 in this instance. So actually, let's take a look at some of the existing systems that they have, they still support, and obviously, the new lineup that they're rolling out now. This here is the AG-210, 10-liter tank. And what's also great about it is it's under 55 pounds, so less regulations for those that are either just getting started or have much smaller fields and don't want to go through all the other hurdles for some of the other systems that they manufacture here. And this here is the AG216. The actual Gen 1 of this was what started it all for Hylio back about 10 years ago. Oh yeah, and this guy right here, the AG272, holds 72 liters, about 18 gallons. And this thing is massive. It was one of the biggest ag drones on the market. Okay, something pretty cool that they just brought me out to. We were just at their manufacturing facility, which is actually just a 1-minute drive away from where we're at right now. But this shipping container that you see right here is where they actually do all the testing before they ship the systems out. And there's actually a system flying right next to me. You can kind of hear it in the background. But yeah, the engineers will be cozied up in here, watching what the system is doing, getting all the logs. They do about anywhere from 10 to 15 flights per system before they ship it out to make sure that everything is mission critical, so that they're not just manufacturing a system and then just shipping it out and telling the customer good luck. They do very thorough testing here. And another really cool fact is where their actual headquarters is at, and this farmland that we're doing the testing on is on 410 acres of actual farmland. So they're not just an ag company that's just building ag drones in the middle of a city. They're actually out here in the field working with real farmers, working with real people to put these systems to the test with true American innovation. Honestly, such an amazing thing to see. So as you can see, we have an actual system right here doing its full testing, spraying, and it looks fully operational. So pretty cool. And where I'm at right now is where it all started about 10 years ago for Hylio. This was their manufacturing facility, which funny enough, this is actually just adjacent to their new 40,000 square foot main headquarters, which is their second HQ, but this was their first one. But as you can see, they are still innovating. They are still trying different things. They're still pushing the boundaries of what's possible in the ag world here in the US.
Back here in the studio, I wanted to take some time to organize my thoughts and share my final impressions of Hylio and their latest generation agricultural drone system. Overall, I was genuinely impressed by what the Hylio team has built, especially considering how far they've come. After iterating through 4 earlier platforms that were based on third-party designs, Hylio has now engineered a system that is fully their own. You can tell they've learned from every prior generation. The result is a drone that feels mature, reliable, and purpose-built for the agricultural market. During my time in the field with their team, the system performed well. We did experience a small software glitch during the beta demo. Nothing major, and something that's fairly common with pre-release software. They were testing a few things in front of me with a beta build, but again, the aircraft itself flew beautifully. The flight control was smooth, and the swarm capability was particularly impressive. Watching multiple drones coordinate seamlessly through their ground control software was something I haven't seen done that well in a while. Even though I'm not an agricultural specialist, the workflow felt intuitive and accessible, showing that both new and experienced operators could get the productive results very quickly. From a user interface standpoint, all the critical operational data, battery health, chemical dispersion rates, mission progress was displayed clearly and logically. Everything about the design communicates usability, which is exactly what agricultural operators need out in the field. Hylio's latest generation system represents a major leap forward, especially with their software now being entirely developed in-house. That's a significant differentiator because most competitors in this segment rely on open source or partially outsourced control systems. By keeping their software proprietary, Hylio maintains full control over performance, data security, and long-term stability. The ground control station itself, built on a custom Windows-based tablet, is well designed and supports advanced features like the real-time telemetry and, again, that swarm management. While there's still room for refinement, the overall system feels polished and purpose-driven. It is worth noting that Hylio hasn't had a perfect history. I've heard from operators who ran into issues with earlier generations, everything from mid-mission disconnects to software crashes and maintenance hurdles. But from what I've seen, Hylio has clearly taken that feedback seriously. The new platform directly addresses many of those prior pain points, and the team knows they still have more to prove. Moving forward, their biggest opportunity lies in continuing to rebuild community confidence, re-engaging those earlier users, acknowledging the past issues openly, and showing the measurable improvements through trusted third-party testing, I believe would go a long way towards shifting that public perception. From my conversations with the engineering team, it's clear they're fully aware of both the opportunities and the challenges ahead. One recurring theme was the cost. Hylio systems aren't cheap, and when compared to the Chinese manufactured alternatives, the price difference is noticeable. But that difference exists for a reason. Domestic production, high-grade materials, and sophisticated software all add up. The team has been actively working to reduce manufacturing costs without sacrificing quality, a big part of why this new generation was developed. Their approach isn't about cutting corners. It's about optimizing processes to make the system more accessible while keeping reliability at the forefront. Following a successful $5 million community funding round, Hylio has been investing heavily in research, development, and software refinement. Much of that funding has gone towards expanding their engineering and programming teams to fix long-standing bugs, enhance system stability, and improve operator experience. Their new 40,000 square foot manufacturing facility, up from their previous 10,000 square foot space, is another sign of serious growth and commitment. That expansion alone gives them far more capacity to meet demand and refine their production flow, which will be critical as they scale. Despite ongoing cost challenges, Hylio's growth over the past year has been remarkable. They've seen over a 200% expansion in just 12 months. And that momentum doesn't appear to be slowing down. Out of the few US companies actively producing agricultural drones, Hylio stands out as one that's truly scaling, both technologically and operationally. Their focus on quality, reliability, and innovation has positioned them as a strong, credible American-made alternative in a market that is still heavily dominated by foreign systems. Looking ahead, I think Hylio's path is clear. Over the next 18 months, if they can continue to refine their software, streamline their production, and increase their manufacturing output, they're positioned to become the most definitive American leader in agricultural UAV technology. I came away from my time with Hylio both impressed and optimistic. Their system is functional, thoughtfully engineered, and it works as intended. Sure, there's still work to do on scaling and cost reduction, but their momentum, investment in R&D, and commitment to continuous improvements tell me they're in it for the long run. More information about Hylio and their latest generation system can be found in the link down below. Now, let's move on to the next system in the showcase.
Now, most commercial and industrial drones that exist on the market are built for mapping, inspection, carrying LiDAR payloads, multispectral, gathering large amounts of data, even search and rescue. But this guy right here, the Lucid Bots Sherpa 1.5, this guy's built for pressure washing buildings, commercial properties. And this flagship setup that they have right here, which we're gonna take a look at very shortly, is gonna be pressure washing this building right behind me here, specifically the windows. So let's take a deeper dive and understand why Lucid Bots are building pressure washing drones. So what are some of the unique features that exist on a pressure washing drone compared to a typical drone that carries a payload? Well, for one, they have this hot swappable or quick connect payload in front. Well, it's your actual pressure washing hose here with multiple different connects. Whether you want a high concentrated beam, a fan, or maybe one to just spread your chemicals. In the front, we have a radar, which actually allows you to get close enough to the building. And the reason why they chose a radar versus a visual sensor versus LiDAR is, well, you got to think about all of the chemicals and water and just all kinds of debris that's going to be in the area in front of the drone itself. So with a LiDAR, that's going to pick up all the particles. With vision, it could get blocked with whatever chemical may be spraying or even just water droplets. So they found that the radar module on here actually allows them to basically go full throttle, we'll see that here shortly, into the building and not actually crash and keep them a safe distance away. They've also got dual RTK antennas. They've actually given me a few different use cases as to why this matters. And given how close they are to the building, you could have different kinds of interference with some of the autopilot, basically the computer of the drone. This allows it to maintain its stability while in flight. Given that the pressure may be on or off from the actual hose in the front, right, it's gonna throw a lot of disturbance. And this is not an equal payload compared to a constant payload of a camera or LiDAR or multispectral. Again, this system is built for pressure washing buildings. You'll also notice that it is a hex design, right? So in the event that one of the motors just fails, you have the other 5 to pick up the slack. They also have a 12S setup here, and it looks like they're running 2 10,000 milliamp hour batteries. So if one fails, you know, kind of standard with some of the other systems that does a parallel system like this, you will have the ability to bring it down safely. They actually also have an FPV camera in the front, so they can actually see on the controller itself what the drone is looking at and what it's spraying. Because on a building like this is only a 4-story commercial building, but this can go all the way up to a 12-story building. And you want to be able to see exactly where it is, given depth perception with being close to a building and a drone kind of gets thrown off. And because the specific mission of this drone is to pressure wash, put chemicals on the building, whatever it may be, you actually need to be able to see what you're doing. Now, something that's also unique is, well, there is no tank here to hold the payload, or there is no tank here. Everything is driven by this, this water hose that you see here. That is all being fed from this custom van that I'm actually gonna show you guys here shortly. It's actually a really cool setup, and they partnered up with another company to build out these vans to make it a very easy and efficient process to get on site and do the job, right? In addition to that, you can see there's a smaller tank in the back here. This one, like I said, this drone is configured for doing the window pressure washing as opposed to just an entire surface. And it gives them the ability, they actually have this switch in the back here that can turn on the pull of the chemicals or turn it off. That way it's just straight water. So you can spray water, put your chemicals on, and pressure wash it away, all without having to take off and land multiple times to disconnect and reconnect the actual tank back here. Now, as for the entire operation, it seems actually pretty simple. And I'm actually gonna be able to get hands-on and really show you how this entire system works and how easy it is to get up and running. But before that, let's go and take a look at the custom van that they have built out for an operation like this. Remember, they built this entire system to make it a whole lot easier and even safer to pressure wash large commercial structures. Because the traditional way of doing it is getting on bucket lifts or putting up scaffolding, right? Stuff that's not necessarily that fun to do and presents a lot of risk. This helps eliminate a lot of risk. Yes, the drone could crash, but they have thought about all of those different scenarios, which is why they have all of these different safety metrics built in that we just talked about. Let's now go take a look at the van and see how it actually supports the capabilities of this drone here.
All right, so this is gonna be a little loud because the actual system is in full operation, but this is the mobile command center if you were doing any data collection. But in this case, this is the full operation center of where all your chemicals are, where your actual water tank is. So you can either operate entirely independent of, let's say, a water source from the commercial property that you're on with the tank that's in. And then up top, you have a high flow system and a low flow system. So 2 different pressure systems for the actual water pressure itself. That gives you a lot of flexibility depending on the kind of environment that you are operating in for doing your pressure washing job. And you can just hear it just kicked on, so it sounds like the system's in operation here. Now what's really cool is they have a high pressure hose, a soft wash, and a water supply. So they're all pretty self-explanatory. The water supply is basically taking whatever source that you're pulling water from to then fill the tank. Your soft wash is for, well, a soft wash, and then your high pressure, which that's what the drone is currently using, a high pressure system, is using that right there. But honestly, a very nice and effective system to be able to roll up to your site, not have to bring a ladder truck or really any complicated system. This here is built for efficiency to operate directly alongside with your Sherpa 1.5 drone.
So operation is pretty simple. They've got a very easy controller to really operate the entire system here. I love this audience right now, by the way. So there's a few different position modes on the drone itself, or on the controller, I should say. They have land, position, and manual. Whenever you want to take off, you got to put it into the position mode. And then it's pretty simple to arm it. So we'll go to the center, wait for the props to spin up. As soon as the props spin up, it's going to be full throttle up. And now we're going to position it towards the actual building itself. And with the radar on that, it's going to sense the building in it. So I'm full throttle towards the building. I'm going to go just a little bit higher here. But I'm full throttle and I can't even go any closer to the building, which that's what you want. So now we're going to start the actual pressure itself. See, it gives a little kickback to the actual drone. And now it's very simple. With the left stick, we're just going to position it left and right. And that's how we get our precise movement. If we want to increase the actual altitude of the drone, we're going to go up. And then if we want to start the actual chemical, they have the injector switch. So we just turn on the injector switch. And now we're spraying actual chemical, and you can see the chemical releasing. Position up, we'll keep just spraying our chemical on, and then we'll turn the injector off. And now we're just spraying water again. So very simple operation of the entire system here. Really not too hard. Let me pull the drone back a little bit so I can just move it to the left. There we go. Now once we get centered to the window, we can just simply go left and right, and you can see how easy it is to move it. So I'm going to go up. And if I want to do this next series of windows, here we go. We'll put some water on it. We'll turn on our chemical, right? We'll spray it in, turn our chemical off. And there we go. So then when we're done of actually spraying anything, we can just turn the entire hose off. We're going to pull the drone back. And just like that, very simple operation. Really, anybody can do this. And funny enough, I actually have an entire crowd here that a lot of this is their first time actually operating a system that's really not that complex. And now welcome to LucidBot's headquarters here in Charlotte, North Carolina. Behind me here is about 16,000 square feet of manufacturing capability, where they host over 70 different employees. Fantastic for a company of their size with 8 years of innovation. Now, this is 16,000 square feet of their main space. They also have another 6,000 square feet on the other side of that wall over there that we'll take a look at. But every single system that they build or fix for RMAs is here. So let me take you around to show you how they build their Sherpa 1.5 systems. Now, the life of every single LucidBot's Sherpa drone starts right here. This is where they store all of the parts, the components, and individual pieces that actually go into every single one of their systems. And something pretty cool is they actually manufacture some of their own pieces themselves with some of the industrial 3D printers behind me. I am definitely a sucker for 3D printers, especially in some of the manufacturing facilities that I've seen over this entire tour. And well, you can see them in action here. Not the biggest cluster of 3D printers, but definitely impressive nonetheless. And as for the actual production line of the Sherpa drones, you can see it right behind me here. Now, they only have one main production line here in this 16,000 square foot facility. They are producing. They actually just hit their 100th or 500th drone, excuse me, not too long ago, and they're on track to hit 1,000 here relatively quickly compared to when they hit their first 100. But like I said, every single Sherpa drone starts right here at the front of the line and makes it all the way down to the back. Given that they aren't doing a very high output, they don't need to have multiple production lines, but that is something that they hope to change here in the near future, especially with the newer facility they're going to be moving into later on. Now look, accidents do happen, so they do have an RMA area to fix any of the systems that may have gone down due to user error or maybe just some weird thing that may have happened. Again, drones are not perfect. They are robots, and based off of, human input, again, accidents do happen. Like I said, they have an entire area dedicated to helping their customers get back up in the air within a few days as opposed to a few months. Something that they actually faced very early on when they were building off of different competitors' frame. Now that they manufacture their own frames and have really their own build, they're able to go through that full RMA process on their end as opposed to relying on a third-party vendor, which makes it perfect for their customers that need to get back up in the air, right? Time is money, so they have that ability right here. And this final area that I have behind me here is the QA. Before any system actually goes out to a customer, they do a full quality assurance test. They actually have a little test area on the other side of this wall to the left of me where they'll take it up. They'll connect it to a typical pressure system that some of their clients may be using and test spray patterns, making sure that the system is fully operational. All right, lied a little bit. I was able to get out here for an actual demo. So you can see they're just doing a quick test with the van setup, but there's also another system behind me here that you might be able to see that they're also gonna get up in the air to go through its full QA, QC test before they actually ship it out to the customer. They're just loading a little bit of chemical in there. They're gonna make sure that it actually sprays properly, which you can see. They're gonna switch it into the actual chemicals. And it's like, there it is. Now it's spraying chemicals. Full autonomous, pretty cool. Now, the previous space that we're just in is the 16,000 square foot of main manufacturing. This 6,000 square feet that we're in right now is their entire R&D team. This is where they test new builds, test a new version of a system that they're working on right now. Can't really say too much about it, as well as some other very cool pieces of tech that they are hoping to release to the market here pretty soon. But any new iteration, any new adjustment, anything new that goes onto the drone that they release to their clients or maybe some upgrades happens right here.
My time in North Carolina with the Lucid bot teams was actually a lot of fun. I've had hands-on experience with drones for mapping, agriculture, hybrid systems, and even VTOL platforms, but never a system designed for pressure wash. And to be honest, when I first heard about pressure washing drones, I thought the idea was pretty ridiculous. That was based entirely on my ignorance. In my mind, pressure washing meant spraying down my parents' single-story house as a kid. So I didn't understand how putting a pressure washer on a drone could possibly make sense. But when Andrew, the founder of Lucid Bots, explained the actual problem they were solving, everything became crystal clear. Commercial pressure washing, especially on multi-story structures, is one of the most dangerous jobs in the maintenance industry. Workers are routinely suspended off the sides of buildings, operating from lifts or bucket trucks at heights that introduce serious risk. Lucid Bots designed their systems specifically to eliminate that danger. Once I had the chance to see the drone in action and get hands-on with it myself, that logic behind it became very obvious. Community perception reflects the same surprise. When most people hear commercial drone, they immediately think of mapping, inspection, or first responder systems, not an industrial cleaning tool. So when operators learn about a pressure washing drone, the reaction is usually a mix of curiosity and genuine shock. And honestly, that works in Lucid Bots' favor. They have almost no direct competition in this space. And the value proposition is easy to understand. Safer, faster, more efficient cleaning for multi-story commercial buildings. Anyone who has worked in or around service-based drone businesses understands that the only tools worth investing in are the ones that deliver clear, reputable value to clients. and this platform does exactly that. In terms of challenges, Lucid Bots is facing a clear bottleneck: production capacity. They recently surpassed the 500 build milestone, but they've already exceeded that number by hundreds more, and they're now supporting multiple large national contracts, many of which have expanded their fleets after the initial deployment. That level of demand is great, but it also means production lead times are becoming one of their biggest short-term issues. It's a good problem to have, but still one that needs to be addressed quickly. The second challenge is cost. At $40,000 per unit, this is a significant investment for a service provider. However, putting that number into context is important. Traditional commercial pressure washing rigs, even without drones, can run into the same price range or even higher. And that's before factoring in liability insurance, which skyrockets when workers are suspended on ropes or operating from lifts. When framed as an ROI tool that dramatically reduces liability and removes human workers from high-risk positions, the $40,000 price tag becomes far more reasonable. Still, it's a large upfront investment, and that's something potential buyers must weigh carefully. Looking ahead, I think Lucid Bots has a very strong future. I spent time with their engineering team, and they have several big announcements on the horizon. Updates that will not only make the system more attractive, but directly addresses some of the concerns I had around production capacity and costs. They already dominate the NDA-compliant pressure washing market in the US, and they intend to hold that position. Their ability to innovate quickly, adapt to customer needs, and create meaningful upgrades with limited resources is actually really impressive. What I appreciate most is that Lucid Bots does not see themselves as simply building a cleaning drone. They see themselves as improving infrastructure longevity by reducing corrosion, improving worker safety, and enabling buildings to be more maintained, more efficiently and effectively. They're creating tools that make hard, dangerous, and expensive jobs safer and more scalable. The system they've built is genuinely impressive and incredibly easy to operate. Obviously, I did that live test in the field, and the workflow was straightforward and intuitive. There's a clear reason why the company has grown so quickly and continues to outpace others in this space. I see a strong, sustained future for Lucid Bots, and I'm genuinely excited for the public to see some of the updates that they have coming up next. To learn more about Lucid Bots, check out the link below. Now let's move on to the next system in this showcase.
Meet the Centero 6, Censys' 6th generation fixed wing VTOL. And yeah, this is a pretty large platform here, but what exactly is this system for, and how did they get to their 6th generation? Let's take a look. Since 2017, when Censys launched their 1st generation platform, they've been a big pioneer in the industrial era for these UAV platforms. Now, obviously we've got the 6th generation here, but let's talk a little bit about their humble beginnings to figure out how we exactly got to the 6th generation here. Now, if you've never heard of Censys before, they're actually pretty well known for their BB-loss capable systems. Obviously, again, we've got their 6th generation here, but it actually started back with their VLOS system all the way to Gen 3. Then when Gen 4 came out, they were able to obtain one of the very first BB-loss waivers for their systems. Now, jump a few generations ahead, they've been able to provide the BB-loss waiver program for a plethora of their clients. And what exactly are these clients using these platforms for? Can't you just use it with a regular quad? Well, yes, you can, but with what you get with a system like this, it's long endurance with great capability in terms of payload options, whether it's photogrammetry, LiDAR, and even multispectral, but it's really the ability to maintain that aerial intelligence factor on multiple different playing fields. Because again, there are a lot of limitations when it comes to the quadcopter platform. With a fixed wing platform like this, it doesn't have to deal with the friction of the wind. In fact, it's gliding like regular airplanes do, which allows for those long endurance flight patterns. Now, these are fully battery operated systems. There is no hybrid engine built into it, and that allows for them to get into a lot of different environments where having a combustion engine may be a big no-no, especially when it comes to power line, oil and gas, or really near the energies sector, or when it comes to the flammable nature of a combustion system. Yeah, this doesn't have to deal with that at all. Now, before we actually get this system up in the air, let's take a full look at how these systems are manufactured,
where they start their life and how they actually end up in a client's hands, because it's actually pretty cool what the Censys team does before these actually become fully operational, alongside with their integrations, the technology, and they're also a software platform that they have that is a very seamless ecosystem that they built out for all of their customers. Behind me here is the full manufacturing facility that you see every single Centero come out. Actually, behind me now, they've retooled the entire assembly line for their brand new Centero 6, which is their latest generation fixed wing VTOL system that Censys develops. I'm gonna take you to each station so you can see where the life of a Centero 6 starts to where it ends up finally in a customer's hand for the full flight test that we'll see later on here. Before any electronics actually make it into the system itself, what you can see here looks like the full nervous system, and it pretty much is that. It shows all the routes, all the cable runs, and where all the logic is gonna go into, well, now the Centero 6. So we've got our flight control, we've got GNSS, we even have their detect and avoid system up here at the front. Everything gets test fitted here to make sure that there are no weak links before it actually makes it into a system itself. From here, it'll then get into one of two different assembly bays, which let's go take a look at that right now. Now behind me, you can actually see one of the two pre-assembly bays. Right here, they're actually working on a Centero 5. On the other side, they have a few Centero 6s that they're doing the pre-assembly on. But once pre-assembly is completed here, and then moves on to the final assembly right behind me. So I'm gonna show you what that looks like, because that's where all the fun components finally get put together before it gets into the cage test area, which that area is pretty cool. We're gonna see that here pretty shortly. For the final assembly, this is where they will do the final test fit of all of the wings, the payloads, the batteries, and even do a full electronic test. Not an actual flight, but a test to make sure everything is communicating the way it's supposed to talk to each other. Once completed here, it'll go into the cage test to go through all the flight parameters, making sure all the motors work, making sure all the links work. So let's go check that out right now. So once the system makes it off the assembly line in the other part of the facility here, it comes into its cage test. Before any system actually makes it outdoors, they run it through a full parameter test to make sure the motors are operating correctly, to make sure that when it needs to bank, it can bank. And this really cool contraption here allows any of their systems to freely spin in this caged environment. And the reason it's a cage is, well, there's been a few, you could probably see, unforeseen incidents of props popping or really anything. So it just keeps it very safe in here. But once it's gone through its full parameter test, it then makes it outside, which we're actually about to see a system live in action here. Censys doesn't just build these incredible systems in terms of the aerial applications. They also specialize in custom outfitting full mobile command centers or mobile intelligence centers. Doesn't really matter which way you want to call it, but as you can see, this gentleman behind me here is putting in a few upgrades for this client that, well, for whatever their specific needs are, they can match it. And every single one is done per client request, which is awesome. And it's not just vans, they can do full trailers, full buses. It doesn't really matter, because these are all very capable vehicles for not just allowing you to monitor what the drones are collecting, whether it's data, whether it's ISR, but also allow you to process a lot of that data in real time without having to ship that data back off to somebody at an office. So this is one of the systems, actually a brand new van that they have here that they're working on right now. And actually they have a few other ones out back that we can actually go take a look at. So let's see some of the different configurations that they have that go alongside with their aerial platforms that they provide for their clients. Speaking of some of the other trailers, this is a more conventional trailer that you can see here. They're actually doing a full retrofit for this specific client. This is an older unit that they did a while ago, and they're updating it now with new electronics, new wiring, and just newer technology. What's also pretty cool is you can also get these large masts. So when they're operating their full BB loss waivers, they can get that mast high enough to be able to have that full line of communication with the systems itself. Yeah, I mean, you can kind of see it's not just about the aerial platforms that Censys provides for their clients, but also the mobile command centers that they specialize in building out and custom fit for whatever the operation at hand needs. Now, not quite a mobile command center, but obviously drone docking has been one of the more popular conversations that's been happening this year for 2025. And this is Censys' version of a dock. Yeah, not quite so small, but obviously it's built for their fixed wing VTOLs.
that they have. This can actually fit an entire Centauro 6 inside, and it allows for, let's say, drone going from dock to dock situations like what we have here in Florida with hurricanes. It's actually a pretty cool piece of tech, and this is their latest innovation that they're working on to go in tandem with not just the hardware that they have, but also the software platform. And finally, before we actually go outside and get hands-on with the Centauro 6, we are here in, well, the entire brains of the operation. So any logic, any control, any integrations that goes into any of the systems that the Censys team provides to their clients starts right here. Any cameras, any payloads, any actual custom retrofit sometimes on the systems themselves is here. Design, I mean, everything, like I mentioned, starts here. It's the brains of the operation before anything actually ever makes it out to the assembly line that we just saw out there. Now, one of the great things about the Censys team here, especially here in this engineering lab, is it's not a cookie cutter operation here. Like, they truly take care of every single one of their clients, making sure that every single one of their needs are met. And if they can't find a solution, they will find a way to be able to provide the solutions for their clients. Doesn't matter what the integration is, doesn't matter what the mission is. These systems are built to perform and outlast a lot of the other platforms on the market, given their long endurance and their capabilities, and most importantly, the BB loss that they've built into these systems here.
VTOLs have always been some of the coolest systems to experience hands-on, simply because of their size, presence, and the elegant flight characteristics that they offer compared to those standard quadcopters. The same holds true for the Centauro 6. Even though I didn't get to see their new version fly in person, I did get hands-on with the Centauro 5 back in 2023. And that was genuinely impressive to witness. Censys doesn't build VTOLs for your everyday run-of-the-mill mapping jobs like the ones I or many other of my colleagues perform in the industry. These platforms are purpose-built for long endurance missions, extended data collection tasks, and most commonly ISR operations for law enforcement and search and rescue teams. And it's no surprise that they do dominate that side of the market. These systems are engineered specifically for agencies and operators who need reliability, the range and endurance that these systems really tout out there. While I don't frequently work with law enforcement or search and rescue operations myself, I can say confidently that I've never heard negative feedback about the Centauro line. In fact, what I have seen is steady growing adoption from agencies and private companies that need a system as capable, stable, and dependable as the Centauro 5 and now the Centauro 6. Censys isn't cutting corners or stuffing in cheap parts to make these aircraft fly. They're sourcing extremely high quality and often expensive components to ensure that these systems deliver maximum reliability in their high stakes missions. The biggest challenge for Censys is the price. A $100,000 VTOL is a serious investment. I joke that for that amount, you could almost buy a small Cessna and fly your own missions and take photos in LiDAR. But again, all jokes aside, this isn't an impulse buy platform. It's a specialized tool built for organizations that need true aircraft-like capability without the cost and limitations of operating a real aircraft. That's why most of their customers are agencies or companies that could afford an airplane or a helicopter, but chose the VTOL route instead because it gives them far more flexibility. They can ultimately deploy these systems practically anywhere without relying on runways or manned aviation logistics. Looking ahead, Censys has an ambitious roadmap. As they continue to build out their next generation of their aircraft, they're also developing their own cloud platform, systems they plan to significantly expand going into the 2026 year. Expect more automation, deeper payload integration, advanced synchronization capabilities, and heavily enhanced AI functionality aimed at search and rescue and organizational workflows. I genuinely see a future where drone-in-the-box automated deployments become a standard in public safety and infrastructure monitoring. And Censys is one of those companies intentionally moving into that direction. They've already demonstrated early proof-of-concept versions of this, which gives me a lot of confidence in where they're headed. Censys was an awesome company to spend time with. Yes, their platform is far outside my personal price range, but that doesn't diminish their relevance at all. They've carved out their place in the market with intention, and they continue to innovate on the VTOL front from a technical perspective. These systems remind me of what you'd see in the military space. Extremely capable, advanced, and mission-ready, but without the multi-million-dollar price tags. The Centauro line is a purpose-built for civilian and first responder tool, designed for a specific niche in the market, and excels exactly where it's supposed to. To learn more about the Censys family of systems, check out the link below. Now let's move on to the next system in the showcase.
Now, I usually evaluate systems from a mapping and inspection perspective, but this drone here has a few unique capabilities that really expand what a medium lift platform can achieve. Let's take a look at why the Flyby Robotics officially launched their system earlier this year. At the core of all three models is the NVIDIA Jetson Orion, delivering 157 teraflops of AI compute power, 16 gigs of RAM, and a 2 terabyte SSD. That means you can store and run all your AI and ML models directly on board for real-time processing in the air. And you can actually add a sub-module to increase that to over 300 teraflops of compute. From a performance standpoint, the F11H can lift payloads up to 2.5 kilos and sustain about a 50-minute hover time, which that's more critical for AI and ISR missions. Even with an LR1 payload and RTK enabled, it can still deliver over 30 minutes of reliable data collection. Radio compliance is another key factor here. For NDA requirements, the Flyby team offers flexibility with HereLink, Doodle Labs, or Silvus radios, giving corporations, universities, and tech startups the freedom to choose what fits their workflow. Obviously, I know HereLink isn't part of that, but you kind of see the point here. Those options define the three models: the F11D for Doodle Labs, F11S for Silvus, and F11H for HereLink. Originally designed as a research and development platform to showcase the onboard compute, the system has also sparked commercial and industrial demand. In response, the team has been developing a beta version of their mission control software to support those users. What stood out to me is that Flyby didn't just reskin QGC like so many others. Instead, they built their own mission control interface from the ground up, which prioritizes seamless integration for developers and end users alike. Now that we covered the background, let's actually throw up this F11H and show you what the Flyby team has built. And really, I want to show you more about their mission control because that is what really stood out to me. So like I said, next to me I have the F11H. This is the HereLink variant of it. I am using a HereLink Blue, so a very familiar controller. Now, what is different was the mission control, like what I was talking about. On here is the custom-built mission control that the Flyby team has built out. Very simple interface, and that's intended in purpose here. So if we want to fly it, we just click on fly, and it's going to load into the actual camera itself. And one thing I do really like is the checklist. It doesn't just pop you straight into the FPV screen. You can actually get a full checklist of every operation that has happened or has not happened on the system to give you full confidence before we actually fly the system itself. Now, on here, before we actually take off, we can see that we're looking at the FPV view, but we notice there is an actual camera on the drone itself. We have the VO from Gremsy. If we want to switch over in the top right-hand corner, we just click onto the VO. And there we go. We've got very easy gimbal control on here. As you can see, we can zoom in. I mean, it's a VO, so it's as to be expected in how it operates. Nothing proprietary there. To take the system off, super easy. I'm just going to go back into the FPV view. And it is a little bit of a windy day, which I actually like when I'm doing an evaluation like this, just to really show how the system functions. Again, all we got to do is click on the arm button here, slide to arm, there you go. So with the way it's doing its position hold right now, I think we've got about 10 to 15 miles an hour of wind right now, which is pretty solid. She's holding steady. The tuning, I also believe, is done really well. It's very responsive. Might be a little bit easier to see on the FPV, but it is a very responsive system itself. So honestly, no complaints there at all. We can see we have full video feed here. I'm actually going to switch back over to the VO, and we have a full video feed directly off of the gimbal itself. Now again, there is a little bit of a lag. That's because I'm not just screen recording, but I've got some other things going on around me that's giving it a bit of a delay. But once again, that just really has to do with where we are in the industry with radios. Everybody is going through the same issues with transmission on the radios. And this system is no exception, but again, From the standpoint of where and how they built this system, it's more around the AI side. So as expected, system flies beautifully. I do really like the tuning that they did on it, given that I have flown quite a handful of systems in this entire project that I've been working on here. So the fact that there is almost no lag in the actual input and what the drone reacts to, that right there gives a whole lot of confidence for operators out in the field, especially when you're spending over $20,000 for a system like this. Really not much else to it. Why don't we actually go take a look at where the team builds all these and actually codes them? Because again, the significance around the Flyby team is that it's all about the AI compute. And they have built a very easy to work on platform, not just on the software side, but also on the hardware end for that full integration. Again, that's the superpower of this system right here.
Unlike the other companies in this showcase, I wasn't able to film a full live talking walkthrough at their facility. So what you'll see in this section will be more of a voiceover paired with B-roll shots of what I captured on site. And to be fair, the reason for that is pretty simple. There honestly wasn't much to physically show. Flyby contracts with third-party vendors to produce their molds for their aircraft bodies and batteries, so their own manufacturing footprint is extremely compact. What they do build in-house is the assembly in what I describe as more of a lab environment more than a production facility. There's a few room for parts, a few tables for assembly, and a small team focused far more on development than on large-scale manufacturing. Despite that small footprint, Flyby is working on something genuinely interesting. One of the standout elements is their AI and machine learning integration across their 3 aircraft variants. Because Flyby developed their own GCS, or ground control system, they have the freedom to add practically any feature they want, and more importantly, to load AI and ML models dynamically, even out in the field. While I was there, they demonstrated loading a model via a laptop and an Ethernet cable, then activating it on the controller in real time. In this case, it was a simple object detection model, nothing groundbreaking by itself, but what struck me was the infrastructure behind it. My mind immediately went to what could be built on top of that foundation. One idea was swarm flight, multiple systems communicating in a mesh network, coordinating tasks simultaneously. Flyby has already achieved this internally, with several drones flying and sharing information at the same time. Another idea was search and rescue. Living here in Florida, and seeing the devastation from last year's Hurricane Helene and the floods in North Carolina, I couldn't help but imagine a fleet of F-11s equipped with EO and IR cameras and AI models capable of detecting human life in rubble, collapsed homes, or rising floodwaters, and then providing responders precise GPS coordinates in real time. With 157 teraflops of onboard compute available on the F-11 platforms, those kinds of possibilities start to feel very real. After the quick demo that you just saw that I did out in the field, I spent a few hours with the Flyby team talking through areas where I'd like to see refinement as they begin positioning themselves beyond pure R&D and move deeper into the commercial sector. And I have to say, they were a fun group to nerd out with. Their passion for AI-driven flight was obvious, and their systems genuinely surprised me with how smooth it was to operate. Even their GCS felt clean and intuitive, which is an achievement considering how much custom development is under the hood. That said, the Flyby team does face a couple of major challenges. The first thing is scalability. Right now, with such a small assembly footprint and external mold production, a timeline of 6 to 8 weeks for a $20,000 airframe without payloads is a tough sell for many potential customers. The second challenge is market presence. Flyby's capabilities are impressive, but very little of what I saw at their HQ is something that I can publicly show or that the industry at large even really knows about. For a company building something this interesting, they need a stronger public-facing narrative and more systems in the hands of real operators. The NDAA compliance is a strong selling point, but compliance alone won't drive adoption. They need visibility. Despite those hurdles, I think Flyby has a promising future. Their platform already checks a lot of boxes. Roughly 50 minutes of flight time with a payload, RTK capabilities, onboard AI compute, and a solid proprietary GCS in an open but controlled environment for deploying models and developing AI applications. If I were more deeply embedded in the AI, ML, or robotics R&D space, this would honestly be my go-to platform. In fact, I've already recommended it to a few colleagues who specifically need drones with NVIDIA compute boards integrated out of the box. Because, as I've said this before, building one drone is easy. Building a company around manufacturing drones is the hard part, and Flyby has already figured out a large portion of that. The next challenge is scaling the operation and expanding market awareness. With the right customers and continued focus, they can absolutely achieve that. In the long run, I think they'll end up competing with some of the larger players in this AI drone niche, especially since most of the other manufacturers haven't focused on that space. Flyby's out-of-the-box development environment gives them a unique advantage that's hard for anyone else to match. For more information about Flyby Robotics, check out the link below. Now let's move on to the next system in the showcase.
When you first hear hydrogen powered, you might picture a complex, finicky system, especially when it's powering something as advanced as a drone. Over the years, a few companies have released hydrogen powered drones, but many fell short of delivering a truly reliable product. That's where this system from Cellen stands out. I got full hands-on time with their, what you see right here, hydrogen powered drone. And to be honest, it turned out to be far easier to operate than I ever imagined. But it still raises the question, why hydrogen? Hydrogen power isn't anything new. For many, the first thing that comes to mind is the Hindenburg disaster of 1937. Nearly a century later, hydrogen still isn't a common energy source in most systems. So why is Cellen investing in it for drones? The answer lies in the team's background. The founders of Cellen have degrees and careers rooted in hydrogen chemistry. This isn't a group of people strapping a potentially dangerous gas to a drone on a whim. They've spent the last 2.5 years developing a system that prioritizes safety, efficiency, and reliability. And to put their claims to the test, I'm not just talking about this drone, I'm actually gonna be setting it up, flying it, and even running some data collection on it. Before we take off, let's look at some of the specs. Starting out with the actual hydrogen system itself. You can choose between a 5-liter tank, which is what's on the system right now, that offers around 75 minutes of flight time with a payload like the 61 megapixel Sony ILX LR1. Or you can opt for a 12-liter tank, which I also have here, that can reach up to about 150 minutes while carrying a very similar payload, or you can even go all the way up to 10-pound payload capacity on this system here. Now, what surprised me the most is actually how lightweight these tanks are. These are fully carbon fiber and basically taking no effort to pick it up. As for the hydrogen itself, it delivers a very impressive energy efficiency, which makes it super lightweight for systems like this, rather than relying on a combustion engine of a traditional hybrid system. It's also virtually zero emissions, making it genuinely green power source. As for the cost of hydrogen itself, it's relatively inexpensive, anywhere from $7 to $20 per flight, which ultimately breaks down to anywhere from 6 to 13 cents per flight minute. The drone itself is built for endurance with a fully carbon frame body, US-made motors, and carbon fiber props for strength and durability. The onboard hydrogen fuel cell outputs up to 2.4 kilowatt hours, which is plenty for not just propulsion, but also powering any onboard systems. This model also supports high-end payloads like the Sony ILX LR1 for mapping and smaller LiDAR units, and even the Phase 1 P5 camera, which has an over 100 megapixel resolution, which is great for some serious mapping and inspection work. Control is currently handled with the HereLink and QGC. Despite the tech inside, the operation is remarkably straightforward. Let me show you exactly how it works by actually showing you setting up the system, getting the hydrogen up and running, and throwing the drone up for doing some data collection. So system setup is fairly easy. So you can see one-man operation here. After that, you're gonna want to get all of your arms out, as well as lock them into place here. Then with the pressure reader that they supply to you, there's a little sensor cable that you plug into it. It's gonna give you a pressure reading of the actual tank itself. They give you the specifications on what that needs to be at so you can safely operate it. Once you've confirmed that, then you want to plug the cable into the distribution interface. This is ultimately what allows the hydrogen to get from the tank itself into the generator down below. Once that's plugged in, we can then attach our quick connect tube into the actual tank itself. And then with your batteries already inserted, you're going to plug in the XT90 into the back. You'll hear a little chime that boots it up. And then we actually need to turn on the hydrogen power itself. You'll hear some fans spin up, and then you're gonna hop onto Q ground control, let everything go through its boot up sequence, and then you'll ultimately be ready to fly. And then taking the system off is pretty much as simple as really any other drone on the market. So as we can see here on the controller, there's actually two different cameras on the system itself. There's a standard FPV camera, which is exactly what we're looking at here. To switch over, we can just hit the settings tab and click on HDMI 2. And now we're looking at the Sony camera that's on there. It can also touch on the screen to basically look at wherever you tap on the screen, so pretty cool. To center it, you click on the little gimbal icon in the top of the screen and click on center, and there we go. So let's go ahead and just get this system up. And it's pretty responsive. There's a little bit of a lag, but that doesn't necessarily hinder the actual performance of the drone itself. As soon as I let go of the props, yes, it's a bit of a heavier system itself, so it's gonna take a few seconds to kind of slow down, but it's all very manageable. Now, flying a system of this size, you're not necessarily gonna be flying it as low to the ground as I am right now. I mean, I'm only just a little under 5 meters off the ground. So let's actually get this system up in the air so we can really put it to the test. Now, one of the questions on how do you actually manage the hydrogen power and basically calculating how much fuel you have left. Well, in the middle of the top status bar, you have a percentage. There's the middle percentage is that 38%. That's basically how much percentage of fuel is remaining in the tank itself. So honestly, it actually doesn't really matter which tank size you use, whether it's the 5 liter or the 12 liter, it's automatically calculated. So you actually don't have to recalibrate it when hopping between tanks, which I think makes for super ease use out in the field. That way you don't really have to think about battery management or a time countdown of maybe doing like a stopwatch or something. It's just all there. Now I've already gone ahead and switched over to the FPV camera, and we can see, I mean, it's a crystal clear view. It's super wide, super easy to get a sense of where the drone actually is up in the air. So operating this is very straightforward. Now, as much as I would have loved to show this system in action with its mapping and the integration that they currently have in place, it's not quite there, but I will say it's not necessarily a fault of Cellen with how the integration works. If you're using a lighter payload or just carrying weight, I mean, this thing operates fantastic. The way that they've integrated the hydrogen with everything else on the drone, it's a flawless execution. It's very responsive, very smooth, and very quiet operation of the system. But when it comes to payload support, this is where something that ultimately falls down on the open source nature that is ArduPilot and Gremsy and Sony and all of these other components trying to talk together. Unfortunately, my time out here with the system, it did not work that well.
I want to wrap up my final impressions and overall experience back here in the studio to better organize my thoughts, feedback, and hopes for the Cellen team and their hydrogen-powered UAV system. Cellen has developed a highly functional and surprisingly easy to fly platform with impressive flight performance and tuning. However, during my testing, the mapping camera integration wasn't operational. The team has since updated me that the issue is resolved and that the system now supports the Phase 1 150 megapixel camera, which is great, but that wasn't my experience in the field. Lighter payloads would likely perform flawlessly on the system, but anything requiring more complex data or communication beyond basic power will need further programming and integration to achieve consistent real-world reliability. The hydrogen component generally impressed me with how simple it was to operate. I required very little training to get the system flight ready, and it's clear the team put significant effort into making the process straightforward. They nailed that aspect. That said, hydrogen technology still faces practical and infrastructural challenges. Refueling options in the US remain limited, requiring specialized equipment and strict safety procedures. While Cellen noted that airgas facilities can provide refills, accessibility and safe handling are still concerns. Hydrogen power has come a long way and offers real promise. But at the current system's cost and considering integration limitations, it's a tough sell. Overall, Cellen represents an impressive step forward in hydrogen drone power, but it needs further refinement on the software and integration side to meet professional market expectations. Cellen is still a relatively unknown name in the drone industry, with only a few systems currently in circulation. From what I understand, I was among the first individuals outside the company to gain hands-on experience with one. They're not the first to explore hydrogen propulsion. Other companies have tried and failed to sustain it, but Cellen believes it can break through and become a leading solution for organizations that need a medium lift, long endurance platform. The two biggest challenges I see ahead are scaling and energy accessibility. At Cellen's current size and funding level, scaling even to a few dozen systems will be difficult. Building a drone is one thing, but building a company around it is far harder. With limited systems in the field, questions around reliability, longevity, and customer support remain open. The second major hurdle is the hydrogen accessibility. In the service world, downtime equals lost revenue, and refueling hydrogen isn't as simple as stopping by a gas station. Even with potential tank swap services, the logistics aren't yet scalable. While advancements are slowly improving hydrogen infrastructure in the US, it may take time before accessibility and cost reach practical levels for operators. From what I've seen, the Cellen team is working diligently to refine their integrations and scaling strategy. I provided direct, constructive feedback while in the field, and they were receptive and eager to improve. As a small company entering one of the most competitive markets in the US, drone manufacturing, I genuinely admire their courage. They face a steep road ahead, but with their upcoming market launch expected soon, they'll gain valuable real-world feedback to build on. Can they overcome these challenges? Absolutely. With patience, community involvement, and consistent iterations based on operator feedback. They'll need more systems in the hands of pilots, integrators, and real-world users to accelerate their learning curve. I am grateful for the opportunity to test the system firsthand. It's one of the best tuned aircrafts I've flown in the past decade. The hydrogen setup was remarkably easy to use, which shows how much thought went into its design. Again, the main bottleneck remains the integration, ensuring all subsystems, payloads, and software communicate seamlessly. Until that's solved, it's going to be hard buyers or leasees to fully justify the investment. The Cellen system stands out as a unique and ambitious platform in the drone market. As a hybrid system, it doesn't fit neatly alongside traditional electric multimotors or VTOLs. It's designed for endurance and moderate payload capacity, making it well suited for industrial and commercial use cases. However, before scaling to wider adoption, the team must refine the software, payload integration, and operational logistics surrounding hydrogen-powered flight. Partnering with third-party experts in the supply chain, field servicing, and component support could accelerate that process. Look, I am genuinely excited to see how Cellen continues to evolve and push their hydrogen-powered drone technology forward. More information about their system and company can be found in the link below. With that, let's move on to the next system in this showcase.
In the spirit of really giving you guys just every single option that exists in the market, obviously I know the main focus of this entire video was geared towards the American-made systems. Even if there are Chinese components in them, they're built or at least mostly assembled and programmed here in the US. That leans more towards that integration side. I did want to add in the NDAA compliant systems too, or at least the ones that I could get access to. And here I have the Parrot UKR edition. Yes, Parrot is made in South Korea, but this specific version of the drone is the NDAA compliant one that can be used on government projects here within the United States. Now, the system is a little interesting. I've been flying it here for the last 2 hours, just trying to get familiar with it, but let me kind of break down my overall thoughts about this system and then just how it functions. Given, well, obviously the small form factor that it is, this is aimed at a very targeted category when it comes to the Chinese competition compared to a majority of the other systems that we were taking a look at throughout this entire video here. Right off the bat, obviously, this is a small form factor. You have the small batteries with the small camera payload that is here on the front. not swappable, unlike some of the other systems that we had taken a look at. But to be honest, I was actually pretty happy with at least the RGB side of it. On the optical side, the thermal, is really kind of my feelings about it. In terms of it flying, it's weird. It's really, really weird. And I want to kind of walk you guys through that in a live flight, but also just show you what feels like a very incomplete build that was put out. It just feels like this thing was rushed to the market to be able to just get that checkbox of it being NDA compliant, which has its caveats. This thing does actually really feel like a toy. It flies for quite a while, but it's just not really that responsive. And the controller, while nice and large, also has its drawbacks. So let's actually take a look at this. Obviously, I'm not gonna be able to show you where the system is manufactured. This is more of just something that you can buy and get here into the US and be able to operate on government projects. But let me just take you through what this offering looks like. I'll let you guys make your own opinion on this here. Let's take this system off for an initial flight, and let me just walk you around the actual interface that you get on the Parrot UKR app for the Parrot UKR drone. So here, what we can see on the left-hand side, we've got the actual camera view itself. Now on the controller here, let me just see if I can get you close up and personal here. There's no dials. There's no dials at all. It's just all like thumbsticks as like the up and down and the zoom, which I don't really like because you'll kind of see why. It's not a lot of tactile control. It's just, you move it, it moves a bit, you move it back just to get it zoomed less or tilted down less or more. I don't know. Let me just take it off. We'll simply just initiate the motors here. All right, great, we're in the air. Now, feedback is a little lackluster. So I'm gonna move the drone forward. So it's kind of hard to tell. I mean, it is moving, but it takes a second for it to react. Now, the one thing that I don't like specifically on positioning the drone up or down or moving it left or right is every time I do it, and let me bring the drone a little bit closer. When I go, let's say, turn to the left or to the right, you can kind of see the drone either drifts up or down. And even though I'm going directly to the left or to the right, it seems like there's a bit of a, I think it's called a deadpan. I may be getting the terminology wrong here. I don't know what's going on with the software wise. When I turn to the left or turn to the right, the drone will either go up or down, even if it's just, let's say like a millimeter of it going in the up or the down position. So it just makes the control of it not fluid at all. I don't really know how to describe it unless what I'm showing here is painting a clear picture here. Now, back in the actual app itself, we can see on the left-hand side, like I said, we've got the actual camera view itself, and then on the right-hand side, we have a map view. Now, I do have my phone's hotspot on to enable the actual internet connectivity, so we can actually see, right? And it's just like any other map. You zoom in, you zoom out, and it'll load the map tiles. Now, let me just re-center the camera here. There we go. So we're just gonna go, oh, just like that. Yeah, I won't try to go up and the drone drop down. Just very weird. Now, I'm just gonna make the actual camera view larger on the screen so it's a little bit easier. And we'll use this pole here. Yeah, you can kind of see. I'm gonna turn right now. It was like a good 1.5 seconds response. So when it comes to just trying to do a very accurate, let's say, inspection, you're gonna be spending some time on these controls and really dialing it in, and just more so being reactive to how the drone reacts in a delayed response. I hope you guys kind of see where I'm going here with this drone. So we're just gonna tilt down a little bit, and I just gotta push it down. It's weird. I wish I had dials on here because that's more of a intuitive, interactive sense on a controller. I know I'm just sounding very scatterbrained here, but it doesn't seem like there was an actual ergonomic engineer that was engineering this controller. It just said, all right, just throw these sticks on there and that'll be good enough for controlling the actual camera. I don't like that. Now, the actual cameras themselves is actually pretty good. So if I zoom in on here, it's got pretty good optical and digital zoom. So we'll tilt up here, and let's say we want to just focus on this point, and this may take a second. Not the easiest. You can kind of see the drone just bounces up and down as well. Yes, I know there's a little bit of wind, but it should not be moving as much as it is right now. So maybe we'll just zoom in a little bit more. And I mean, I'm not even really that far. The drone is 37 meters away from me, and I'm having some weird just transmission issues here on the video feed. But it just looks like it's focusing on the back. So let me just, yeah, this is just not very intuitive at all. Okay, there we go. Now it finally focused. Now maybe I want to switch over to the thermal camera. There's a button that I can switch over, and it does this weird overlay. There we go. Now it decided to work. Let me zoom out a little bit. Zoom out some more so you can see. Yeah, it does this weird just doubled up overview, so you can see the RGB and the thermal together. And then if I click it one more time, it'll go fully thermal. And yeah, we can zoom in. You know, decent quality, but I really feel like this system was just a checkbox just to have another small form factor system to just throw into the market for those specific government projects. Now, the one thing that I had happen, let me recenter the camera here again, and I'm gonna go back into our RGB view. Let's bring it close to me. I'm gonna actually bring the drone directly over top me. All right, it's right over top of me. We can see on the screen, it says it's no meters away, but I'm gonna go straight up. And when I was doing my testing, I was up at about 50 meters. Yeah, and it just cut out. I'm trying to bring the drone down to me, and it's not even responding at all. Oh, there it goes. Yeah, now, literally in real time, I was trying to force it to do something, but yeah, the entire video feed cut out. I was up at 55 meters. That should not be happening on this system at all. Let me actually bring it down, because now it's just making me feel a little uncomfortable having it that high. But yeah, I had the system 55 meters above me, and the entire video feed cut out. I actually lost control of it. I was pulling the stick down to bring the actual height of the drone down, and nothing was happening. It took a good 5 to 10 seconds for it to come back. I don't know. This drone is weird. I like the camera on it. The interface here, you can see it's not responsive at all, and that's not how a system should be. Nothing should be really forced to be put into the market just to check a box. But again, I get it. I'm not the one who's forcing these upon us. But this just is not, it's not a superior product. I mean, I hate to bring this into the mix, but literally all the B-roll that you guys have been seeing from all the systems is with this drone right here. Yeah, Chinese, I know. I'm a hypocrite for flying this in the video, but I mean, it is still one of the best systems for the camera drones that exists out there. Where this, I don't like it. I really do not like it, and I'm really trying to like it as an alternative small form factor option when it comes to doing the inspection work or maybe even search and rescue, which, I mean, good luck with this thing.
To clarify up front, I fully understand that the Parrot UKR is not a US manufactured aircraft. However, it is listed as an NDAA compliant system, which led me to expect more from a small form factor platform positioned for professional inspection and mapping. Unfortunately, my experience with the system was severely disappointing. And to be fair, I'm open to the possibility that I may not have operated it exactly as intended. But when I shared my concerns on LinkedIn, I was met with pushback suggesting that the system is excellent and that perhaps I misunderstood it. That may be true, but based on what I personally saw and experienced, this drone felt drastically overpriced and overpromised for the role it's supposed to fill. For a platform that cost $22,000 as a kit, what I was met with felt more like a toy from 2012, the era when I first started flying drones, rather than a modern professional tool. Community feedback mirrors that mixed sentiment. Some people strongly defend the system as a great alternative for data collection in commercial and industrial applications, but others, especially those who were with me during that UKR trial felt the same frustrations I did. The camera quality wasn't convincing, the thermal felt off, and the responsiveness of the aircraft felt reactive rather than proactive, if that makes sense. In a workflow that demands precision and reliability, that kind of inconsistency is simply not acceptable. Look, I don't enjoy being overly negative towards any system, but this drone genuinely needs a complete overhaul. Again, at $22,000, it feels cheap in the hand. The radios clearly need major reworking, and the GCS would benefit from a far more intuitive controls and functionality. Parrot is a well-established company with a long history in the drone industry, and the fact that this is their offering for a professional NDAA-compliant small form factor solution does not do their legacy any justice. To offer something more constructive, there is a pathway forward. First, the price needs to come down, and by a lot. Second, the system needs more dedicated R&D time to address the bugs and reliability issues that I experience, especially the connection problems. I should not be losing signal when a drone is directly above my head under normal flight conditions. There is simply no justification for that. With more engineering time, refinement, and a stronger focus on optimizing the radios and camera pipeline, I can easily imagine a version 2 of this platform becoming a legitimate contender in the US market. The overall idea of a compact NDA-compliant system that handles mapping and inspection makes sense. The current execution just isn't there yet. Right now, my takeaway is that the Parrot UKR needs more time to mature before it can be taken seriously as a professional tool. Otherwise, it risks becoming one of the most expensive paperweights in the NDA-compliant market. Not by choice, but by design, because the issues that I face fundamentally hinder its ability to perform. There is absolutely a path forward for Parrot to turn this into something more compelling, but they need to acknowledge that this version simply isn't ready for the audience that they want to serve. I don't enjoy being harsh, and I fully respect the resources it takes to build a platform from scratch. But at the same time, if I'm spending $20,000 to $25,000 of my own money on a professional tool, I need to know that I can rely on it. And there are several other systems at this price point that I know for certain would perform reliably in my line of work. The Parrot UKR, in its current state, would do the opposite. It would hinder me. More information about the Parrot UKR can be found below. Now let's move on to the next system in this showcase. I didn't want to close out this video without mentioning a few other US manufacturers that I did not get a chance to meet with due to time and budget constraints. This will be in no particular order, but I still want to give a highlight to the other players in the market. I know I will be missing several other companies, but these were the ones that came to mind and ones that I wanted to visit in person. When you look at where Harris Aerial sits in the growing landscape of US-made drone systems, they fill a very specific and increasingly important gap. Heavy lift, long endurance multi-rotor operations. This isn't a company trying to recreate a DJI style all-arounder. Instead, Harris is building platforms for the people and organizations that need to fly big payloads for extended periods of time, whether it's LiDAR, hyperspectral sensors, radar packages, or other mission-critical equipment. Their core platform, the Carrier H6, is one of the few US systems that can genuinely operate in 3 different power formats: electric, hybrid gas-electric, and even hydrogen. That swap between them within minutes. That alone positions them uniquely in the market because they aren't just offering a drone. They're offering an adaptable flight platform that matches the mission. In practice, the H6 and H6HL lineup are all about combining endurance with capability. The electric configuration gives you respectable flight times, but the hybrid and hydrogen variants are where Harris stands out, delivering multi-hour missions with real payload on board, not just a spec sheet number. For large corridor mapping, forestry analysis, long-range agricultural assessments, or sensor packages that simply cannot fly on a typical mid-range system, this platform has a very real advantage. And with the heavy lift H6HL pushing payload capacities close to 90 pounds, you're playing in a class where you're normally talking about helicopters or fixed-wing specialty aircraft. This is where Harris becomes relevant. They offer the versatility of a multi-rotor with the uptime and lift capability needed for serious industrial work. Now, none of these systems come without trade-offs. Systems like these naturally introduce more complexity, hybrid engines, fuel cells, and ground support gear, and overall maintenance demand a more experienced operator and a higher tolerance for logistical overhead. This isn't a platform you'd buy for your everyday photogrammetry jobs. It's a system you deploy when you have a specific, heavy, long-duration mission profile that requires hardware most drone pilots never really interact with. That means a smaller community, fewer tutorial resources, and a user base that's still growing. On the flip side, the people who are flying Harris rigs tend to speak highly of them, praising the build quality, the engineering philosophy, and the support from the team. Where Harris ultimately falls in the commercial and industrial space is at the top end of the capability ladder. They're not chasing the middle market. They're building tools for power utilities, DOTs, forestry agencies, LiDAR integrators, and operators who routinely fly expensive, specialized payloads. They've leaned heavily into the US manufactured and NDA aligned narrative, positioning themselves as a long-term compliant solution for government and enterprise missions. With the industry shifting away from foreign dependency and toward American-made hardware, Harris Aerial sits in a strong strategic position, especially as the demand for larger sensors, higher endurance, and mission-specific platforms continue to rise. If the US drone industry is moving toward a landscape defined by purpose-built platforms rather than a one-size-fits-all airframe, Harris Aerial is a clear example of what that future looks like. They may not be the loudest company in the space, and they're not trying to win the Best Beginner Drone Award, but for operators who need hours of flight time, serious lifting power, flexible power systems, and US compliancy baked into the design, Harris Aerial has carved out that niche that is only becoming more relevant as the industry evolves. And I also want to mention that they do have an H4C in production that should launch early 2026, so hopefully we'll get to learn more about that system in the near future. But for more information about Harris Aerial, that can be found below. Let's talk about this next system. Arcsky is one of the more interesting US-made manufacturers stepping into the commercial and industrial space, and they're doing it with a purpose-built approach rather than trying to mimic the consumer drone playbook. I first learned about Arcsky back in Las Vegas at the Commercial UV Expo in September earlier this year, where they were unveiling their latest system, the Explorer. And even from that first look, it was clear they were aiming to solve real-world operations, not just show off a shiny new airframe. Their platforms, especially the X55 and the new Explorer, lean heavily into modularity, payload flexibility, and true mission endurance. The headline numbers, like the X55's ability to run hybrid power for multi-hour flight or carry heavier LiDAR and inspection payloads, show that Arcsky is targeting serious operators who need range, lift, and reliability more than they need flashy marketing. Meanwhile, the Explorer fills the opposite end of the spectrum, a compact, ruggedized workhorse designed for mapping, inspection, and public safety crews who don't need heavy lift but still want US-made and NDA-compliant workhorse. Where the Arcsky shines is in the areas that matter most to enterprise operators: payload integration, the workflow simplicity, and the compliance. Their master payload connector, rail mount system, the RTK and PPK support, the hot swap power setups all contribute to a system that feels thoughtfully designed for real field conditions. As the market continues to shift towards the domestic hardware requirements, especially in the government, utilities, and critical infrastructure environments, Arcsky's designed as assembled in the US approach becomes a real competitive advantage. They're clearly paying attention to where the industry is headed, but they're not without their challenges. Like most emerging US manufacturers, the biggest hurdles for Arcsky are scale, the ecosystem maturity, and long-term field-proven reliability. Their hardware is promising, but they don't yet have the massive support backbone that most established brands have built over the past decade. And while the X55's 3-hour endurance numbers look great on paper, it's important to recognize that those times drop significantly once you start hanging real payloads underneath it. So operators should plan missions using realistic numbers. As they continue growing, their ability to deliver consistent support, production capacity, and real-world performance will be what determines how they stand in the long run. From what I've seen and heard, community sentiment around Arcsky is cautiously optimistic. People like the direction they're headed, appreciate the American-made angle, and are excited to have another serious contender pushing into the industrial UAS space. Most are waiting to see broader developments, stronger user testimonials, and more long-term operational data before fully committing, but the interest is definitely there. In the bigger picture, Arcsky fits right into the emerging generation of US-based manufacturing, trying to carve out a meaningful position in a market that was once completely dominated by the offshore hardware. They're not trying to be in everything to everyone. Instead, they're staying in their lane and building platforms for professional operators who need heavy lift, long endurance, compliance, and real workflow flexibility. And in that space, they're building a solid foundation. They're still early compared to the giants, but Arcsky is absolutely a name worth keeping an eye out as the American drone industry continues to mature and scale. You want to learn more about Arcsky? Again, check that link down below. Let's check out this next system. SIFLY is one of the newest names stepping into the US manufactured drone landscape, and they're doing it with a bold claim, dramatically extending what an electric motor can do in terms of endurance, range, and mission flexibility. In talking about commercial operations, their Q12 platform is designed from the ground up for industrial-grade operations, long duration mapping, and large-scale infrastructure inspection, search and rescue, as well as public safety missions. And honestly, really any workflow where operators are tired of swapping out batteries every 25 to 30 minutes. With reported flight endurance pushing into the multi-hour territory and a payload class that can support real serving sensors, the Q12 is clearly meant to tackle missions that today often require either a hybrid drone or simply a manned helicopter. All of that is wrapped into an NDA-compliant US-made airframe, which aligns directly with what so many agencies and enterprise clients are now demanding. From a capability standpoint, SIFLY is pushing the industry towards what a fully electric drone should be able to accomplish. Longer forward flight ranges, quieter operations, modular payload support, and onboard autonomy layers are all strong selling points. For a mapping and LiDAR professionals, an audience I serve heavily through my training and consulting, longer endurance means fewer flights, fewer breaks in data, and more efficient workflows. The platform isn't just aimed at surveyors though. It's positioned as a true multi-role industrial tool, and that opens it up to a variety of verticals looking to modernize their unmanned operations with American-made hardware. That said, SIFLY is still early in its life cycle. The specs look incredible on paper, but like many young companies entering the commercial space, the big questions revolve around real-world validation, long-term reliability, manufacturing output, and whether the payload ecosystem will be mature enough to support the higher-end sensors that many industrial users demand. And while the Q12 is slated to ship in early 2026, the true test will be how it performs in the hands of actual service providers doing real-world work, not controlled demos. As for what the industry thinks, the sentiment is a mix of excitement and curiosity. Media coverage has been extremely positive, especially around the Q12 endurance numbers. Many see SIFLY as a potential breakthrough for long-range electric operations, and as a legitimate US alternative for agencies who can't or won't purchase foreign-made systems. At the same time, there's a healthy skepticism because so much of this is new. A startup with big promises has a lot to prove when it comes to the supply chain stability, again, those real-world mission performance, the cost of the ownership, and as well as the data workflow integration. Overall, most people agree that SIFLY represents the direction that the industry is headed. Oh, and they also have a Q1250 that's going to be launching in 2027 that's supposed to be able to carry over 200 pounds and have a 100-mile range, which that's crazy. Ultimately, SIFLY fits into a very specific space in the commercial and industrial market. It isn't trying to be a DJI replacement in the traditional prosumer sense, nor is it competing with the ultra heavy hybrid platform designed to carry 30 to 50 pound payloads. Instead, it sits right at the intersection of high endurance mapping, public safety deployment, industrial inspection, and large area data acquisition, a niche that's becoming more important as BVLOS operations inch closer to widespread approval. As a US manufacturer, SIFLY is moving toward a future where long-range electric drones, not hybrids, take over the mid to large-scale mission category. If their real-world performance matches the ambition they're pushing forward, they could become a major player in the next wave of American-built industrial UAV platforms. More about SIFLY can be found in the link down below. Now, let's move on to the last system that we're going to be talking about. Another US manufacturer I want to highlight is one that many in the industry may not be familiar with yet, Fowado Technology Group. They're aiming to bring a medium-lift American-made alternative to the market with their cruiser lineup, specifically the Cruiser L, which is their newest platform. Josh, the founder of Fowado, is actually a good friend of mine. He sold me one of my first enterprise drones nearly 7 years ago. So hearing that he was developing a US-built platform definitely caught my attention. I haven't had the chance to get my hands on with the Cruiser L yet, but from what I've seen, it looks promising and intentionally engineered for real-world use. Like many of the established companies in this space, the Cruiser line is built around NDAA-compliant components, supports multiple payload configurations, integrates with an easy-to-use ground control system, and offers flight times of 40 minutes or more depending on the payload setup. One of the things I personally appreciate most is how compact the system is. both in its unfold configuration and how small it packs down. As someone who travels frequently, that level of portability is a major consideration when selecting the right aircraft for different projects. I think the best part is the cost. Right at $16,000 for a ready-to-fly kit, it makes it a very attractive option for serious operators like myself. That said, familiarity doesn't guarantee success. Even though I have known Josh and Fowado for a long time, they still have a lot to prove in the commercial drone industry. They need more visibility, more media presence, and more real-world demonstrations to show the community what the Cruiser L can really do. Manufacturing capacity is another important piece. While they can produce a handful of systems each month, the real test will be whether they can scale when demand increases. With so many components sourced from NDA-compliant suppliers rather than built in-house, questions inevitably arise about parts availability, RMA logistics, and how they plan to support larger organizations that may need multiple units. These challenges aren't unique for Fowado. Every manufacturer faces them, but I am hopeful they can resolve those quickly as they continue to grow. More information about the Fowado Cruiser L can be found in the description below. Now, let's wrap this whole thing up. This was by far the hardest project I have ever worked on. I've put well over 1,500 hours into the travel, the hands-on testing, the filming, and the editing. And just to reiterate, not a single dollar came from any of the manufacturers that you saw here. I truly wanted this to be an unbiased look at the current state of US drone manufacturing. I do have to say, several of these companies genuinely surprised me with what they're bringing to the table. Are any of them perfect? Absolutely not. But when you look at where the industry is headed and the pivots that many of us will have to make to keep delivering mapping, LiDAR, inspection, and other mission-critical services, this showcase represents the reality of what's available today. I am hopeful for the future, but we still need more innovation, faster iteration, and the component cost to come down significantly. The truth is, most of the industry can't justify $15,000 to $20,000 systems. We need more US-made drones in the $1,000 to $5,000 range, but I just don't see that becoming a reality for another few more years. Here's where you can do your part. If you have any comments, suggestions, or critiques about any of the systems in this video, direct them towards the manufacturers. They are all watching this and genuinely want to know what you want improved. So use the comment section below and make your voice heard. If you have enjoyed this video, please give it a like. This project has consumed 3 months of my life. And if you want to see more content like this in the future, please consider subscribing. Thank you again for sticking through this long. If you stuck through this long, I seriously appreciate you. With that being said, I'll see you guys in the next one.